grabbing their lunches. If you all could do me a favor, though, I know how much you like to sit on the ends, but if you could move in, that would be great, because otherwise the people in the back of the room are going to step on you in the middle of the talk, and it's probably going to be uncomfortable for both of you. So please move in towards the center. We are trying to accommodate a number of people, and I really appreciate it. Also, there's a bunch of seats in the front row, and I promise to not pick on you more than once if you sit in the front row. So welcome, welcome. Today I'm here to talk to you about DevOps versus SRE. This is a hot and contentious topic. Which one's better? Which one's worse? Are they the same thing? Are they different? Competing standards or friends? For those of you that don't know me, my name is Seth. I work on the developer relations team at Google. I've been at Google about 1.5 years now. Prior to that, I worked at companies like HashiCorp and Chef Software, which are kind of regarded as leaders in the DevOps space, similar to other tools like Puppet or Ansible or Salt. And I've been involved in this DevOps space for quite some time. I've written popular tools, I've contributed to popular projects, and I've watched this movement kind of from the beginning, really since about 2007, 2008. And I'd like to share my perspective today on what I think DevOps is and how it relates to SRE, or Site Reliability Engineering. So with that, let's go ahead and get started. In the beginning, there were two groups of people. On the left, we have developers. Developers are concerned with agility. They want to build features, build software, and ship it as quickly as possible to get it in the hands of customers and users. On the right-hand side, we have operators. Operators are concerned with stability. It's not broken, please don't touch it. And this wasn't just a personality thing. This was driven by the business. As an operator, it was your responsibility to make sure that the system never went down. And when the system went down, you got a phone call or a page in the middle of the night, and it was your responsibility to fix it. And if you didn't do it in a timely manner, you might be fired. But then on the flip side, the developers have all of these roadmaps and Agile and Jira tickets that they have to complete. And if they don't complete them and they don't get them into production, they're not delivering value to the business. And the business is suffering, and then they're at risk of getting fired. And these are two competing ideas. As we introduce new features and new functionality into a system, we also introduce instability. Every new line of code we write has the potential to have a bug, has the potential to have a performance regression. So these are directly competing ideas. We have developers who are trying to move quickly and introduce instability, and operators who are trying to slow things down as much as possible because it's not broken, please don't touch it. But here's where things get a little bit interesting. Developers were closer to the business, both physically and metaphorically. Developers often sat in the same building as the directors and the vice presidents and the CEOs. They were physically located closer to the business decision makers. Operators, on the other hand, were often in a data center. Their desk might be hundreds or thousands even miles away from the corporate office. They often felt disconnected. They felt like their ideas weren't being heard. Educationally, these two groups of people often came from different backgrounds. Developers traditionally had a software engineering background, computer science, information systems, computer engineering, something along those lines from a 2 or 4 year degree or more. Operators tended to come more from a practical background. They might have like an associate's degree or a practicum in something like network engineering. So there's a skills gap on both sides. Developers are really good at algorithms and writing software. Operators are really good at understanding network topologies and failure scenarios. And how redundant does a SATA drive actually need to be in order to have this many nines of availability? But because developers were closer to the business, oftentimes they would just write their code and they would throw it over the wall to the operators. That animation was nice, right? Yeah, I worked really hard on that. So these developers would throw their code over to the operators. And they'd be like, here's my PHP. Please go run it for me. Thanks. Have a great day. And these operators, remember, they don't have a traditional background in software engineering. They may have never worked with these languages before. In addition to their responsibilities of keeping the network up and running, making sure hard drives are not failing, making sure that servers are not faulting, they now have to understand bugs in the application. Because when that application goes down, they're not paging the developer. They're getting paged. They're getting woken up in the middle of the night for a bug in the application code. But because developers were closer to the business, when operators would complain, no one would listen. So the DevOps movement, really in its purest form, is about breaking down that wall between developers and operators. I know that was another nice animation. By breaking down the barriers between developers and operators and aligning the incentives between them, we can deliver software better and faster and more safely for our end users. What are some ways that we can do this, though? Well, one of the easiest ways that you can break down the barriers between developers and operators is to put them in the same physical room. This has been shown to work successfully time and time again. It's a time-tested pattern. Instead of having your operators go sit in the data center hundreds of miles away, put them in the same room as the developers. Make them attend stand-ups. Make the developers listen to the operators. And all of a sudden, you'll start to have these amazing conversations where developers will they'll try to write some algorithm or some distributed systems problem, and they'll have this great thing, and it works great in theory. Then you have an operator that steps in and says, so that's great, but you're telling me that you need 40 gigs a second for network traffic. And our data center is running Cat5e cable, which is maxed at like 10 over short distances and 5 in reality. So that thing that you're trying to do works great on paper and works great on your local laptop, but it will never work in production unless we upgrade the cabling in our data center. And just that small collaboration saves the company millions or even billions of dollars investing in a software project that cannot be successful because the underlying hardware won't support it. And this is just one example of how putting developers and operators physically in the same space helps improve the software delivery cycle. If you look at the DevOps Manifesto, there's kind of 5 key categories that DevOps is broken into. The first is reducing organizational silos. And I've already talked a little bit about this. How do we reduce the silos that exist between developers, the people writing code, and operators, the people making sure that code continues to run? What we quickly found, though, is that that was just the biggest mountain. After you reduce the silos between developers and operators, who knows what the next giant mountain is? Security, legal review, marketing, PR. All of a sudden, those little things become the new mountains. And this is where the DevOps movement, in its purest form, if you're a DevOps purist, you're like, no, it's just developers and operators. But in order to actually do this successfully, you'll see that it has to involve cross-functional teams. The same way that we want to involve operators in the development lifecycle, we also want to involve the security team. Because if we involve the security team early, instead of our security and privacy review taking 6 months for someone who has no idea what our product does, who has no understanding of our core business goals, we instead have someone who's regularly attending our stand-ups, they're regularly contributing code and reviewing code, and then when it comes time to actually do the review, they may be able to complete it in weeks instead of months. Ultimately delivering software faster, but also safer, because they're far less likely to miss something, right? Reviewing 100,000 lines of code is much harder to spot a bug than reviewing 1,000 lines of code versus 100 versus 1. The second piece of the DevOps Manifesto is that we have to accept failure as normal. If you recall earlier, I talked about being fired a lot. Developers are worried about being fired if they don't ship features. Operators are worried about being fired if they don't deliver 100% availability. This is not okay. This doesn't create a culture in which people, humans, can thrive. We have to accept failure as normal. Any system that humans build is inherently unreliable. And in fact, I would challenge anyone to find a system in nature that is 100% reliable. Most systems fail given large scale. So given that anecdote or that lemma, we have to accept failure as normal. It has to be built into the core of our business, right? We can't just fire people every time the system goes down. Instead, we need to plan for it in advance. So as a concrete example, let's say we're doing a database migration. We're about to roll out a database migration. Before we do that, let's plan for failure. Let's accept that failure is going to happen. So before we actually roll out that database migration, we're going to plan a rollback. We're going to write a script that rolls back our deployment and rolls back the changes to the data model. Well, why would we invest that effort in advance? It might just work. And you're right, it may totally work, and that was wasted effort. But the problem is if it fails. If that deployment or that database migration fails, now your phones are ringing, your pagers are going off, social media is blaring, your boss is yelling at you, your boss's boss is yelling at you, the site is down, you're losing money, and you're trying to build a plan. It's not the best time to build a plan. The best time to build a plan is when there's not a lot of pressure and you can think clearly. So by accepting failure as normal, we understand that bad things are going to happen. There's going to be bad deploys. There's going to be bad database migrations. How do we recover from them? We need to think about that before we deploy them. On a similar note, the next kind of piece of the DevOps movement is this idea of implementing gradual change. If you work in a waterfall software development methodology, you may deploy once a year, twice per year. And the problem is if you're doing that, you're deploying hundreds or millions of lines of code at one time. And the chance that there are no bugs in those million lines of code is effectively zero. It is very, very small that there are 0 bugs in a million lines of code. I don't care how good of a software engineer you are or how rigorous your discipline is, there's going to be a bug. So you deploy the software, and some users start complaining. Well, now you only have to search through a million lines of code to find the bug. It's not that long. It might take another year. Versus deploying small incremental changes. If we deploy, say, 10 or 100 lines of code at a time, if all of a sudden our monitoring starts failing, our users are yelling at us on social media, our boss is telling us that something is broken, or our internal users are saying, hey, this is slow now, we know exactly where to look for the problem. The smaller that change, the easier it is for us to identify the problem. And the faster it is for us to fix that bug or roll back the change. Rolling back a million lines of code is a lot harder than rolling back 10. Now, on the flip side, and this is my soapbox for a moment, I don't like when people measure DevOps success in deploys per day. I think deploys per day is actually a bad metric for success in this industry. You'll see it a lot where people are like, oh, we deploy 6,428 times per day. And I'm like, great, I can add a comma to some Java 6,486 times per day. Like, that's not very exciting to me. But the frequency at which you deploy relative to your business and relative to your industry is a signal. It does tell you how well you're practicing these methodologies. If once per week is standard for your industry, maybe you're in something like fintech or banking where there's regulatory requirements and that's the industry standard, that's fine. You don't have to catch up to some startup that's deploying 100 times a day. What's important is that you're implementing gradual change with respect to your business and your industry. End soapbox. The next piece of the DevOps movement is this idea of leveraging tooling and automation. And this is where you'll often see people confuse tools like Chef Puppet, Ansible, Salt, Terraform as DevOps tools. And that's because those tools largely guided the DevOps movement. They largely supported that DevOps movement, and they coincided with the DevOps movement. So a lot of people are like, I'm a DevOps engineer. And I'm like, what do you do? And they're like, I write Terraform configs. I'm like, OK, maybe not the appropriate job title. That's fine. But leverage tooling and automation is a key piece of the DevOps movement. What we found is that after breaking down those barriers and after accepting failure as normal and implementing gradual change, it turns out there's just a lot of work, like creating users, installing packages, building Docker containers, monitoring, logging, alerting. Like all of those things take time. And if you're a company that has 100,000 VMs and you need to roll out an OpenSSL patch, you can't have people sit at a keyboard, SSH into them, and run yum update. It doesn't scale. And we quickly learned this, right? We quickly learned that we have to have tooling, we have to have automation in order to successfully implement DevOps. Because otherwise, you're just constantly chasing your tail. You're running around putting out fires, when instead we need to be leveraging automation and tooling to make things repeatable and to make a pattern out of these. Another key point is that humans are inherently very bad at doing the same thing over and over and over again. We get bored, we get distracted, ooh, look, a butterfly. Whereas computers are really good at doing the same thing over and over and over and over again. So we should leverage computers for doing the same thing over and over and over again. And the last piece of the DevOps movement, computers are hard. The last piece of the DevOps movement is that we have to measure everything. It doesn't matter if you do all of these things. If at the end of the day your boss comes to you and says, how much more successful is the business? And you say, people are happier. That's not a business justification, right? And I'm not saying that we should be justifying everything we do with money or deploys per day, but we have to have numbers to support the efforts that we're driving. If today you don't have any metrics, and you implement all of these DevOps things, and everyone feels better, and you know that the business is better, but when your manager comes to you and says, hey, we've invested $2 million over the course of a year, we hired a bunch of people, we bought these software packages, we invested in this tooling, what do you have to show for it? And you don't have a tangible metric to be able to point to, it's unlikely that the effort will continue. And on the flip side, if you don't measure everything, how will you know if you're actually successful? You have to set clear metrics for success. And that includes at the organizational level, but also at the application level. Now, there's also a difference between measuring everything, monitoring everything, and alerting on everything. These are very different things. You may measure CPU usage, memory usage, available disk space. You may monitor available disk space, but you may only alert if no one can use your checkout page. Because if a disk is full, that sucks, but hopefully you're running in high availability mode and some other service can take over, and a human can clean that up during normal business hours. All too often, I see people adopting DevOps and they jump right in and they start alerting on every metric. And they don't understand why their phone battery keeps dying. CPU usage is at 30%. Oh my God, 30%! Why? We need to measure and alert on things that matter to our users. Is the checkout page working? Can people actually buy things from our e-commerce site? Can our internal users run their analytics and their reports? That's what matters. That's what we alert on. Then we measure the other things so that when we get that alert, we can find the root cause or the root causes that triggered that alert. So what you'll notice here is that these are all abstract ideas, though. I know this is shocking. You had no idea this slide was coming. These are all abstract ideas. I gave you some examples of how you might, say, reduce organizational silos, put people in the same room. I gave you some examples of measuring versus monitoring versus alerting, but they're abstract ideas, right? The way your company might accept failure as normal is very different than the way another company might accept failure as normal. And what we found is that a lot of companies don't like abstract ideas. They want more concrete implementations. So, story time. Independently of DevOps, around the same time, though, Google started this discipline called SRE, which stands for Site Reliability Engineering. It was an engineering-based discipline, so kind of on the engineering ladder, the engineering pay scale, if you will, of people who build and maintain reliable systems. Their job was to keep, at the time, things like search and ads up and running all of the time, or as much of the time as possible. So SRE is kind of like a very prescriptive way to do DevOps. And this is why you might hear us say this phrase every so often, which is that class SRE implements DevOps. Let me explain what I mean by that. So SRE evolved independently from DevOps. It was kind of, Google was really in its own little bubble at that time. And they arrived at SRE as the way to build and maintain and run production systems at scale. And DevOps was kind of built by the community, and SRE was kind of built by Google at the time. Very recently, we've learned that SRE should be shared with the world. For quite some time, Google thought that SRE was like our secret sauce, if you will. It was the thing that differentiated us from our competitors. It was the thing that differentiated us from other cloud providers. We shouldn't talk about it. It's a secret. We didn't even post job postings for it. But very quickly, we learned that there's a language to SRE. There's nomenclature. There's ways to think about production systems that as a cloud provider, when we go to a customer and we start saying these words, we start talking about these concepts, they have no idea what we're talking about. So we go to a customer and we say, hey, this service has 3 nines of availability and you're depending on it, which means you can never have more than 3 nines of availability. And our customers just look at us like, nines? Question mark? Like the German Shepherd with the head tilted sideways? And this is when we decided that SRE doesn't have to be a secret. It doesn't have to be a secret sauce. And in fact, other companies can practice SRE. And then Google stepped outside of its bubble and realized that there's already a practitioner-based community, the DevOps community, that is trying to do this. They're doing it successfully in some cases, unsuccessfully in other cases, and that's because it's not prescriptive. DevOps is like an abstract class or an interface in programming. It says, here are the things you should do. Go figure it out. Whereas SRE is a concrete implementation of that class. It says, here's how you reduce organizational silos. Here's how you accept failure as normal. Here's how you measure everything. And this is why we say class SRE implements DevOps. Now, just like in programming, you may have an abstract class or an implementation of an abstract class that has other methods that are not in the interface, right? You may have additional methods, additional functions that aren't in the interface. And SRE is the same way. There are things in the SRE discipline that aren't really part of the DevOps interface. But SRE does satisfy the DevOps interface. And let me show you how. So if we go back to the previous slide where we kind of talked about the 5 key areas of DevOps, how does SRE reduce organizational silos? Well, the first way that we do this is we share ownership with developers. So SREs at Google share ownership with the developers by using the same shared set of tooling across the organization. So there's a single set of tools that both software engineers and SREs use for production systems. And by leveraging the same set of tools, you have software engineers contributing, you have site reliability engineers contributing, and you start to build high-performance, very reliable tooling that helps people get their job done. On the other side of the organization, SRE has very prescriptive ways for which we determine the availability of a system. And the way that we do that results in almost forced conversation and forced collaboration between product teams, developers, site reliability engineers, and even sales and post-sales organizations. How does SRE accept failure as normal? Well, one of the ways in which we encourage that collaboration I just talked about is through these things called SLOs, service level objectives, which I'll talk about more in detail in a bit. But these service level objectives, in addition to kind of forcing collaboration between these different groups in the organization, they also force us to admit how reliable or how unreliable our system can be. And by having that conversation, we immediately admit that our service is going to have faults. And as a developer, and as a product owner, and as a site reliability engineer, I can determine how much fault I actually want my product to have. If I'm building a product that is, up against some competition, it needs to hit the market very quickly, I may accept more risk so that I can deploy faster, I can deploy riskier changes, etc. If I'm building a product that is targeting, say, the healthcare space or the aviation space, that needs more nines of availability. That has to work all of the time. We can't have hours and hours of downtime. We have to have redundancy and availability, and that may slow down our development velocity. But this is a conversation that occurs between the product owners, the developers, and the site reliability engineers. Additionally, as you might expect, the SRE discipline strongly encourages blameless postmortems, which are popular among the DevOps community as well. When an outage occurs, it's nobody's fault. And instead, we try to find ways in which we can improve the system moving forward. Something that SRE does that DevOps doesn't do is that we then generate metadata about our postmortems globally across the company. So for example, at Google, we know that the vast majority of our outage come from a bad configuration change. And that's a publicly shared statistic. And the reason we know that is that in addition to doing an isolated postmortem about an incident, we then categorize and catalog all of that information into a database where we can run reports and gain statistics about what is causing these overall outages. And that can help you build kind of meta tooling and better improve the system overall. SREs implement gradual change by moving fast to reduce the cost of failure. Again, small iterative deployments are strongly encouraged over large, 100,000, multi-100,000 line changes. Tooling and automation is really a key piece of the SRE culture. In fact, SREs have this thing called TOIL, T-O-I-L. I'll talk about it more in a little bit. But TOIL is this idea that you should be spending on times that bring long-term value to the system. So you should be investing your time and investing your resources in things that bring value to the system in the long run. SSHing into a system and restarting a service doesn't bring long-term value. It brings immediate-term value, but that's something that we should fix in the long term. So SREs invest heavily in tooling and automation in order to automate this year's job away. That's kind of an unofficial tagline among a lot of SREs at Google, is that the manual tasks that I did this year, I shouldn't have to do again next year. I should automate those away. And lastly, we measure everything. We measure systems level metrics, but we also measure things like TOIL, reliability. And we'll talk more about reliability in a bit. But hopefully this is clear as to why we say class SRE implements DevOps. SRE is a very prescriptive, very concrete way to satisfy the DevOps interface. So given that, let's jump into a few key areas that I think are important to discuss. The first is SLIs, SLOs, and SLAs. Oh my. An SLI is a service level indicator, something like request latency or requests per second or failures per request. They're a point in time or an aggregate point in time of a particular metric about a system. Basically, an SLI tells you at any given moment yes or no for a metric in a system. Is it healthy or is it not? And you define that, right? So for your system, healthy may be that the ratio of successful requests to failed requests is less than 1%, right? So 99% of your requests are successful. So at any point in time, if you imagine a point in time, that's a binary operation, yes or no. At this moment in time, are we up or down per that metric? Then an SLO is a binding target for a collection of those SLIs. So while an SLI is like a point in time, if you imagine for calculus, if you were to integrate all of those points over a time period, like a quarter or a half or a year, that's where you get your SLO from. So the SLI measures up or down, and then the SLO says how much up or down can we have in a particular time period. Again, like a quarter or a half. Then there's the one that you probably heard of before, which is an SLA. An SLA is a service level agreement. This is a business agreement that happens between a customer or a consumer and a service provider. The SLA is typically based on the SLO. Ideally, you want to break your own internal SLO before you break an external SLA, because violating an SLA typically means you have to give money or credits or reparations in exchange for violating that SLA. So SLIs drive the SLOs, because remember, the SLO is basically an integral of the SLIs over time. And then those SLOs inform those SLAs. But to give you a better understanding of kind of who is involved in this process. I built this handy slide. So product, SRE, and software engineering work together to build those SLIs, up or down. Then the SREs and the product work directly to determine what that looks like over a period of time. And again, this is a function of how fast do we want to move, what are we up against in the market, how much risk are we willing to accept, what's our target market. And then SLAs are generally built by the sales teams and the customers, maybe with some negotiations from product. But they have to be tighter or less than the SLO. Because again, you want your SLO to break before your SLA breaks. And sometimes SLAs are also used as part of a sales engagement, right, where you can like buy more availability. So that's not really part of the SRE conversation, other than the SLO informs kind of the minimum baseline for the SLA. So I often get this question, which is like, okay, so you have this SLI thing and then this SLO thing, and then like, what happens when you like go over? You're like, okay, my system needs to be 99.99% reliable. That gives me like 12.5 minutes of downtime per quarter. What happens when I'm out? Like, can I just keep pushing? Do I fire my developers? Like, what happens next? Well, this is where error budgets come in. So one of the things that's important to note is that it is nearly impossible to find a system that is 100% reliable. And it is often cost prohibitive to build a system that is 100% reliable, especially when you're relying on third-party components. Take, for example, this two-dimensional material phone on the screen. This phone has 99% reliability with its cellular network carrier. This is actually pretty standard in most countries. That's your SLA with your mobile carrier provider. So your mobile provider is saying that we will service 99% of your requests. So 1% of your requests will fail. So let's say you have some backend service, and you have an unlimited amount of money, and you say, we want 100% availability. So in order to do that, you would have to run your own fiber connections with redundancy to every cell phone tower in the country of your choosing in order to be able to deliver maybe 100% availability. And then you'd need your own kind of internet backbone to run that, and you would need on-call people pretty much constantly. Even if you did all of that and invested millions, if not billions of dollars, the user would only experience your app at 99% availability because they're governed by the least reliable components of their system. So even if you have 100% connectivity between your data centers and the cellular network towers, that end user, will only experience 99% availability because they are governed by the least reliable component in the system. And this is a key point, is that optimizing for 100% availability isn't just difficult, oftentimes it's irresponsible. It is not in your company's best interest to optimize for 100% availability. Instead, you should be accepting failure as normal and understanding how much failure is available for your system. So like I said, that user only experiences 99% availability. So how do you determine how much risk your service can tolerate? How do I know how risky my service can be? Well, there are many factors to consider, like fault tolerance, availability, competition in the market, how fast you're trying to deliver, whether there's a giant conference that you need to launch at. That was a joke. But your acceptable risk dictates your SLO. So if you have a product that has really critical market timing, and you know that you need to deliver features quickly, you may say, hey, we're only going to offer 90% availability, because we need to be able to move quickly. And we don't want to have to focus on reliability right now. We want to focus on shipping new product and new features. But again, if you're in a different industry like healthcare or aviation where reliability is super important, you may say like, hey, look, we only want to focus on reliability right now. We need to improve our nines of availability so that our customers can trust us. So as long as your SLOs are met, you can continue pushing new features and new product. But what happens if you violate that SLO? What happens if you've exceeded your error budget, which is the amount of failure you can have within your SLO? Well, then everyone just like plays ping pong, right? That's how this works? No. You can continue deploying. Your developers can continue building features, but everything has to focus on reliability. They can't ship new features until we improve the reliability. So the development efforts, the focus shifts from building new features and delivering new features to improving reliability and improving the availability of the system until the budget is replenished. So just like a bank account, where you get a paycheck and the money goes in, and then you buy some Pokemon cards, and then the money goes out, and then you get more money, right? The error budget works the same way, is that after we've exhausted our bank account of error, we can only focus on reliability. We can only deploy features that focus on reliability or bugs that improve reliability. So what does that actually look like? Well, here's kind of a prettied up version of an internal graph. So on the top, we have the health of the system, which is measuring the number of requests that are under 300 milliseconds at any point in time. So this is like an SLI. In the middle, in the green, we have the compliance, the up or down, are the sum of the requests under 300 seconds. So you'll notice that that's more of a step function because it's binary. It's yes or no. You're either above or below the line. And then at the very bottom, we have the budget of non-compliant requests in our SLO budget. So how many requests are remaining? And what you'll notice there is pretty far on the right-hand side, there's a drastic increase in our latency. So you'll notice it's a little bit confusing because the chart goes down, which is a decrease in the number of requests under 300 milliseconds, which is an increase in the number of requests over 300 milliseconds, right? So we see a drastic increase in latency. That obviously causes our compliance to drop significantly. And then you can start to see that just like my bank account, all of that starts to drop in our budget, right? We start to see a massive drop because we have a prolonged violation of our SLO, right? And it's a steady decline until we're back in compliance. And then we gradually gain a little bit more error budget because time is moving on. And then we start declining again because we have a regression. And these types of charts help inform how much availability your system actually has. And when we're at the bottom of that budget, we have to focus on reliability. So you might ask yourself, well, what just prevents developers from saying, well, like, I know I'm at the budget, but like, this is an important feature. Why can't I deploy it? Well, they can, but they might lose their SRE support. So remember that SRE is a discipline, it's a separate organization that partners with the software and product teams. And if the product team and the software team are not willing to be adequate partners, the SREs will gladly hand you the pager and walk away. At which point, now developers are not only responsible for building new features, they're also responsible for the reliability of the system. And I guarantee you they'll start improving the reliability of the system that night at 2 a.m. Another thing I want to talk about, because I get a lot of questions about it, is toil. It's a fun word, toil. It's like foil, but with a T. Toil is best described as what it's not. It's one of those weird things. Toil is like not email, it's not expense reports, it's not meetings, it's not traveling. These are all things we call overhead, right? Things that are required to do your job that pretty much everyone in the organization needs to accomplish. Toil is actually something that is manual, repetitive. Most importantly, it's devoid of long-term value. It's often incredibly tactical and highly automatable. Classic example of toil is like SSHing into a system and restarting a service because it's out of memory or it's out of spiking CPU usage or something crazy, right? That's incredibly tactical. Like right now, doing that, graphs go back down, everyone's happy, but it is devoid of long-term value because that service is likely going to out of memory again, and you're going to have to do it again, and it's going to be repetitive. And it's manual, but it is very easy to automate. Right? That's a classic example of something that's very toily. And in the SRE discipline, we measure toil and we talk about toil because it's a very negative consequence of the job. If you're constantly working with toil, this can lead to like career stagnation. No one got promoted for restarting servers, right? How many people got promoted because they restarted a server once? Right, exactly. No one. And at the same time, a little bit of toil is also good. So there's a careful balance here. And every year, we kind of send out a survey to all of the SREs at Google, and most SREs aim somewhere between 10 to 20% of toil in their job. So you might ask yourself, where is toil good? It sounds like this is terrible. I should automate everything. Well, if once per year you have to do some very complex operation, like some aggregate report that spans multiple systems, and it's very complex, and it would take you 20 hours to automate it, but it just takes you 15 minutes to do it manually, and you only need to do it once per year. It is not a good return on investment for you to spend time automating that. Instead, you should make sure that other people on the team know how to do it, so that you're not one person, documented, etc. But you shouldn't waste more time automating something than it takes to do it over time. It would take 100 years for you to reclaim that time. No, it would take you 125 years to reclaim that time. It's just not worth it. Toil is also an excellent way for newcomers, like interns or people new to the team, to learn the system. There are better ways, but one of the best ways to learn a production system is to explore it, right? And being able to poke around and understand systems and understand how they work with one another, that's very toily, but it's also a great learning opportunity for newcomers to the team. Another value for toil is that, how many people have ever had a bad day? Wow, that's like, you are all so positive people, right? Okay, how many people have ever had a straight, 6-hour meeting day? I know that you've all had that, yeah, right? And then at the end of 6 hours, you have 475 unread emails. You basically feel like you've accomplished nothing for the day. And then you get a page that, this server's out of disk space. And you can fix it. Then you can go home for the day, and you feel like you've done something with your life, right? Toil can actually satisfy that, right? Toil provides that instant gratification, but in small doses. At a large grand scale, we want to eliminate toil as much as possible. We want SREs to be focused on improving the reliability of the system and the availability of the system, not performing toily tasks unless absolutely necessary. So I've given you kind of a brief overview. You may ask yourself, where can I learn more? There's this happy link at google.com/SRE, where you can find all of this information and a bunch more, including 2 free books. That's free ebooks. The first is the Site Reliability Engineering book. I like to call this the Theoretical Calculus book. And then there's the Site Reliability Workbook, which is like the problem set, if you will. They're both excellent books. The SRE book talks a little bit more about the theory and the history. The workbook is a little bit more practical, a little bit more hands-on, and there's an entire section about how DevOps and SRE relate to one another. Both of these are free. Did I mention that they're free? And you can download them for free. If you would like a print version, you can purchase them from your favorite book vendor. So to kind of conclude here, is SRE DevOps 2.0? No, it's not trying to be. I also hate when people put 2.0 on things. Is SRE trying to overtake DevOps? No. Lol. And I learned yesterday that I'm the only person who pronounces lol. I thought people pronounced it. Lol. Can I adopt both DevOps and SRE? Yes. As I said before, right, if you implement DevOps, if you follow the SRE workbook and the SRE book, you will be satisfying the DevOps interface. On the flip side, if you satisfy the DevOps interface, you might not be doing SRE. There are a number of other disciplines, like VictorOps has a thing called ProdOps. There are other disciplines that satisfy the DevOps interface but are not SRE. Is DevOps dead? I get this question a lot. Like, no one really talks about DevOps anymore. I think that's because it's not dead, it's just assumed now, right? It's assumed that you're following some or all of these principles. Is my talk over? Yes. We have about 5 minutes for questions. There are 2 microphones in the middle of the room. If anyone has questions, please line up at the microphone for the recording. While folks are lining up, if you have a question that you don't feel comfortable asking on the microphone or on the recording, that is my Twitter handle. Feel free to tweet at me at any time. My direct messages are also open, so if you have a question that you want to ask, you don't feel comfortable asking in public, feel free to send me a direct message. I will get back to you as soon as possible. And with that, we'll go to the first mic.
All right. Hello, thank you. Great talk. My question is simply, when you're measuring metrics the way you've described, and you've got SLOs, SLIs, etc., how do you deal with the situation where the metrics start to become more important than best practice, in the sense that people will put in kludgy solutions, or a system will restart itself over and over kind of on a loop because people have figured out that obviously with the right tooling in place, you don't have to make it work especially well. You can satisfy the SLA by putting in these kinds of hacks, and those add up to technical debt over time, which isn't a metric and makes people's lives harder. How do you kind of strike the balance between those things?
Yeah, so if I understand the question correctly, how do you prevent people from hacking the SLO, just to meet the bar? I think there's a few ways that you do that. The first is with code reviews, right? Ideally, you have leadership, technical leadership that is preventing those types of hacks from making their way into your code base in the first place. There's also a certain part of the product discipline, which is that you might actually want to accept technical debt in exchange for delivering a product faster. So it's not necessarily a bad thing once, but it definitely can't compound over time. There's no standard answer to that. I think the best one is make sure you have good technical leadership to make sure that those types of kind of hacky bug fix type things are not just thrown about the code base, but are few and far between. But they're also not uncommon to see, especially in a large code base. I don't know who was first.
So my question, you mentioned that you measure toil. How do you measure toil?
Surveys.
And the second thing I'm curious about is, do you have a measurement for the security of your system?
Cool. So the first question is surveys, so self-reporting surveys. That's a fun question. We have ways internally in which we express, not quantify, but express the security of a system. One of the talks that I'm giving this year, kind of out on the road, is called How Many Nines of Security Does Your System Have? So I'm actually trying to start that conversation around what is a common metric or a common phrasing that we can use to describe the security of a system, the same way we talk about availability of a system. But right now, there's no common standard at all. Sorry.
Hello, Seth. Pleased to meet you. It's been an honor. So when we talk about operations, we have heard about hard drives, bare metal machines maybe. So when we think about serverless architectures, do you think that the operations role is going to disappear?
So the question is, in a serverless world, where does ops go? I can tell you for sure that there are people at Google who make sure that Cloud Run continues to work, right? They carry a pager, they're SREs, they're doing that operations role. I think over time, the role will change, right? Kubernetes changed the role a lot with being an orchestrator and a scheduler that does that restarting, and it has health checks and liveliness checks. It's a constantly evolving space, right? The things that SREs cared about 10 years ago are different than what they care about today, and that's going to be different than what they are in the future. I don't know exactly what that's going to look like, but I don't expect the discipline to disappear. I do expect the focus to potentially shift.
Thanks, sir.
Okay, thanks for the talk. So my question also related to SRE role. So SRE engineering sounds like more for a cross-project person, right? So I'm thinking, do this SRE should be involved in the application architecture design? For example, when the new project starts, the REST architecture and the technical tech need to stack. So does this SRE need to weigh in his thought, or do at least be consultant?
So that's up to your organization and the availability of SREs, right? At Google, the ratio of SREs to software engineers is much lower. There's far fewer. So they are a commodity. They're a scarce resource. But if you have availability, I would strongly encourage you to involve them early, because by involving them early, you can find bugs or potential concerns early and resolve them early without actually investing a ton of development time. I think we're out of time. I'll meet you afterwards to answer your question. Thank you all so much.
Good afternoon. Please welcome Vice President Atos, Ashok Balasubramanian.
Good afternoon, everyone. If you really look at it, applications today are the backbone of digital. And in today's session, we will walk through on how to create an application-centric cloud. And how do you really look at an application-centric cloud from an enterprise context? You're just going through some, yeah, OK. So about Atos, we are a global leader in digital services. We are about 12 billion euros in revenue. And we have about 120,000 of our associates working with clients across 73 countries, providing digital services across all layers of the stack. So that's who we are. And if you look at it, Atos and Google announced a very strategic partnership, what we call as a Atos-Google Enhanced Alliance, just about a year back. And we're essentially focusing on areas of data, intelligence, cloud, applications, all integrated in a common secure platform to provide digital transformation to our customers. And we've taken a very unique approach to take a labs approach. So we have digital and AI labs all across the world, across Europe and North America, to help our clients accelerate their digital transformation. And when you look at the Google Cloud and specific to how enterprises adopt the Google Cloud, there are 6 tracks that we feel are extremely critical that help enterprises scale when they do their digital transformation. So first one is application agility. So we'll be talking a lot about it today. Second one, there is tremendous amount of ERP and COTS on how do you enable platforms like SAP on a cloud-native platform on GCP. IoT is one of those amazing use cases where you really see the need for ubiquitous access across billions of devices, providing real-time performance across both at the edge, swarm, and back at the cloud. So we're investing in an ecosystem of IoT solutions, partnering with Google to provide enterprise adoption of IoT. Collaboration, again, a great use case along with GCP. So Atos Unify platform is working closely with Google to provide a seamless global collaboration to bring in a digital workplace. AI, all the data that comes in from the applications, all the data that comes in from IoT. So we're really collaborating to bring in industry solutions that connect data and provides intelligence back to the decision makers. And all of it secured through what we call as our secured hybrid cloud. I'll talk about it in a bit. So if you look at Atos on cloud, we are about 15,000 people, a little over 10% of our associates are cloud experts supporting our customers globally. And we have taken a very industry-focused approach. While cloud is a large utility, we have taken an industry-focused approach to say, what does cloud mean from a healthcare perspective? What does cloud mean from a capital markets, from a trading perspective? What does it mean from a payments perspective? So we've invested along with Google in creating industry solutions. And we are kind of home to one of the world's largest hybrid cloud today. And we continue to be a leader in cloud, cited by leading analysts across Europe and the world. And we today are uniquely positioned as an end-to-end provider in terms of cloud solutions. And what do we mean by end-to-end? Atos today, along with Google, is one of the very few providers that can provide the entire stack. Because enterprises, if you really look at it today, have a blend of legacy infrastructure. You would have some sort of a private cloud. You would have some sort of a public cloud that you would want to get into. So you would need an integrated provider that can provide that seamless experience for a customer who is embarking on digital transformation, which essentially says, hey, if you are going through a journey, do you have the right infrastructure that can scale? Do you have the right technology patterns that can help you develop faster, and is that secure, and is it scalable? So if you really look at it, we are powered right from a legacy infrastructure stack all the way to private clouds, which we are launching along with Google, the Google Kubernetes engine on Atos infrastructure, which is managed, and public clouds, which are a managed service from us. On top of it, there is a seamless DevSecOps layer and a middleware. And on top of it, through our cloud studios, we provide digital transformation solutions, right from modernizing things that are on legacy to actually refactoring applications, building cloud-native applications, and from a cultural perspective, how do you, bring in an agile workplace? And all of it managed through our automation platform, Zenbots, to provide always-on applications and infrastructure from a business perspective. So coming to the topic for today, I think it's the time in many decades where technology is core to the entire transformation that is around us. So if you really look at consumers and digital disruptors, we are reimagining the way that right from transportation to healthcare to retail and whatnot, people are reimagining the experiences through technology to say, hey, how do I do something through mobile? How do I do something through omnichannel? How do I do something through a different platform or IoT? So we are seeing this ubiquitous access across multiple different ways in which consumers and digital disruptors are reimagining things. So that's a great scenario where technology can play a key role. And on the other side, if you look at it, providers like Atos and Google, we are providing an entire ecosystem that says, right from your cloud infrastructure to applications, middleware, IoT, blockchain, AI, user experience, all of it is available today. And if you really think about it, I think we are at a crux of changing technologies where if you could take some of these experiences and apply some of these transformation technologies and monetize them, that is digital transformation, right? It looks so easy. But unfortunately, from a large enterprise perspective, the picture looks slightly different. So I would look at it this way, where there are a lot of ideas, and each division some division wants to go on an IoT journey, someone wants to go omnichannel, someone wants to do a real-time payments platform, someone wants to do something else. So you have a lot of ideas in the enterprise today, and I think enterprises today have as rich or better ideas than digital disruptors today. But there is something called as the legacy, which is the legacy way of thinking, legacy way of doing app dev, legacy way of how your technology is. So what we essentially call as this legacy burden is kind of holding back a lot of these ideas from becoming digital realities. And within certain groups, we do see certain breakaway groups, which essentially say, hey, I don't care about the legacy. I have a phenomenal idea. I'm an independent digital group. So you would see some untethered balloons that go away and create a certain app or create a certain experience. But unless it's all tied back as a common approach, you would see those balloons either popping or hitting the ceiling, waiting for a critical mass. So what we're essentially seeing is this whole idea and concept of a legacy way of working and legacy as a technology is kind of slowing down and impeding the way that enterprises could really transform. But when we talk to a lot of our customers in this segment, if you really look at it, the way enterprises have differentiated over the last 10, 20, 30, 40, and some are even 100 years old, is by understanding their partners, understanding their consumers on how they behave. And that is something that has made them extremely successful over the last many years. And if you really look at it, that differentiation is today encoded within the legacy applications and the legacy rules which are there within what is called as a legacy burden. So if you were to really look at it, what we think in one side of the coin as a burden is also what truly has differentiated the enterprise today and what's made them win in the marketplace today. So we really looked at it to say, hey, how do we bring best of both together? You have a beautiful cloud and all those technologies on one side, and you have a wealth of information hidden within what is called as a legacy burden. How do you bring both so that the enterprise can truly get into what we call as digital liftoff. So we really looked at it to say, instead of multiple ideas trying to float off and try to do something while hampered by this legacy. So we really looked at it to say, first thing, if you really look at the legacy as knowledge, then you can really convert what is the dead weight that is there into an equivalent of a booster rocket that can actually propel an enterprise into where they need to go. And second is key part of it is automation, and we'll talk about it in a while, on how the whole idea of automation can be a bridge between legacy. Because end of the day, most of banks are 60, 70, 80% on legacy infrastructure and applications today. And it's not going to go away tomorrow. We can wish it away, but it's not going to happen. So we're really looking at how do you leverage automation as a bridge between that legacy world and the new world. So automation truly becomes a backbone in bringing a unified experience between the two worlds. And the last is agile, on how can the payload really keep track of how the business is changing and then go where the business needs to go. So we're seeing this combination of how could you convert what was your business rules and knowledge hidden within your legacy burden as a true knowledge input to the future, automation to bridge gap between the old and new worlds, and an agile way of working on the new age platforms to increase velocity of how you would deliver. And if you were to really look at it, what's stopping them, right? What's stopping us from really looking at applications and knowledge stores which are there today in legacy and converting them into agile-ready applications? So there are multiple layers, and we've had different theories. We started off with 15-factor application. We had then 12-factor and multiple factors. So we said, let's call it X factor because we are competing with each other to create n number of factors that are really required to make an application scalable and available. So bottommost, if you look at it, if you remove the infrastructure dependency, you make your application really portable. So you can put it on any cloud. So that's the first step of where you could literally move it to Google Cloud. Then if you look at it to say, will it really scale? Will it really seamlessly work? Will the business, as the business grows, will your underlying apps and infrastructure grow? So which is where we really are looking at a really decoupled architecture. How good are your contracts between your services? Are they consumer-driven contracts, or are they rigid contracts, and how can they be decoupled? And top of it are, again, proprietary frameworks that over different points of time, enterprises have invested into different proprietary frameworks. How could you really get off those proprietary frameworks into a stateless architecture is the next level of maturity. On top of it, I think two areas, I think telemetry and resiliency go hand in hand. On can you really measure on how your application is performing? And if you can measure how your application is performing based on the different business needs, can you then architect it from a resiliency perspective of talking to your PaaS, scaling up and down? And if you really look at it, it's all interconnected from bottom to top. Unless you have one stack of it, the other stack doesn't work well. And very top of it comes the deployment architecture, which essentially says, can you really isolate a certain business change, and can you deploy that? And we have had even customers where it takes 2 days to deploy a single application, and that might not be a very unique situation. But there do exist. So while you would do Agile, you would do DevOps, you would do a lot of things, but the DevOps train takes 2 days to build, deploy, test, roll back, and go on. So the deployment architecture becomes critical to isolate business functions and ensure that you can provide that real-time deployment from a business perspective. And security, privacy is critical. So while in a legacy enterprise, we would have done all that, how do you ensure that you can actually port it into the cloud as well, which becomes equally secure and is regulated as it needs to be? So when do we do it, right? So it's not a point-in-time situation. So when an enterprise goes through, there are point-in-time situations as well, which means you would look at maybe a couple of data centers and say, hey, this data center estate now needs to be modernized. So we go through situations where we do a business audit and analysis of set of applications, and then say, now you would kind of make it GCP ready, you would upgrade it, you would modernize it, and then go through it. So the one side of it, the first two boxes are point in time where you really look at where you are, how you would need to do an uplift and modernize it. And the last one is something as, how would you integrate a DevSecOps lifecycle that ensures that anything that you build new is that X-factor compliant so that bad code and bad architectures don't get into what we are building for the future. And so I think that's a fairly straightforward approach. I think if you look at the approach, we said simple things. We said, hey, you need to decouple, you need to improve your architecture, you need to make it scalable, and you could do it in a structured way. But then the complexity comes in because it's not one application, it's not one situation or one pattern. You have millions of lines of code and thousands of workloads across the enterprise. And tens of patterns. I think if you're very lucky, we will get into tens of patterns versus thousands of patterns that exist today. So idea is to get it to tens of patterns and few hundred developers who might be trying to run at that speed to essentially say, hey, how can I get all of this running into a new cloud native platform? So we have taken efforts to solve that issue. And to walk through that, I would invite Pawan Trivedi, my colleague, principal consultant at Atos. He will walk through on how we have actually made that an automated solution. Pawan.
Thank you. Okay. Thank you, Ashok. Okay. So continuing from where Ashok left out, as you look at the problem of cloud migration, there are really three problems we are trying to solve. Number one is scale. Number two is complexity. And number three is flow. What do I mean by that? We spoke about tens of developers trying to migrate maybe 5, 10, 15 components at the same time. We already know that the apps are complex. Now, given those two dimensions, imagine all of that thing is also changing at the same time. So the way we have solved this problem and we are trying to present it to you today is based on creating an automation workbench. So essentially what we would do is say, can I solve these three problems and these three dimensions of migrating to a cloud, be cloud ready or cloud native, through an automation platform, right? And the sample that we have chosen today is a typical heavyweight to a lightweight container demo application where typically you would have changes around the J2EE spec or some configuration changes. And we'll show you how an app that can be taken from an on-prem environment and can automatically be ported to the cloud.
A separate environments repository that stores the status of each particular environment, again using that branch segregation methodology. So it has a JSON schema representing each pod, and as well as the underlying containers of that pod. That represents the current version of that pod in that environment. So this environments repository, we look at it at the UAT branch. Again, similar process as before. A pull request is created from QA to UAT. That pull request is then approved. Code is merged into UAT with the versions from QA. And then once that happens, that new commit triggers a build on the UAT branch in Travis CI. Then in Travis, it checks out the UAT branch in every pod defined based on that environment JSON configuration I mentioned. Every image in the pod repository UAT branch is then updated to reflect the version that was mentioned in that JSON config for the requisite version of that pod. The changes to each pod's deployment YAML are then committed to the UAT branch of that repository. So it orchestrates those changes across all of the different repositories for each service. Each of these new commits trigger a build in UAT, in the UAT branch, the pod UAT branch in Travis CI, that then actually, again, goes through that same process, builds the container, makes all the appropriate configuration to change request, and pushes that through to Kubernetes. All right, so next, just to get you a little bit of a representation of what this looks like, I'm going to switch to this demo to sort of see basically what our source repositories look like. So As I mentioned, I'll start with the environment JSON configuration. So as I stated, we have an independent repository called environments. Within that, we have an environments JSON that has the appropriate configuration values for each pod in that environment. So we have a ton of different pods with a ton of different containers. Again, we're using this branch methodology, so we switch between dev, prod, QA, and UAT, and those all will have different configuration values based on the respective version that's being utilized in that environment. Similarly, the other point to represent, as I stated, we have separate repositories, so our source code in this case for the web application is all hosted in this single repository. And then we also have pod configurations, again, as represented in the independent repository. You'll notice, obviously, the source code is where all the devs are going to do their work. The pod is, in this case, managed and monitored by a headless user that Travis CI uses. And as I stated, that will then update with the appropriate image as I represented in that earlier slide as well with the correct configuration value. Another key point to be aware of, all of these, as I stated, all of these tasks that I'm representing that are happening within the CI are all scripted out in our application. In this case, because we have so many services, they all share similar configurations in how the CI process works and how we plan on utilizing it. We have a common CI repository that forms the basis for all the scripts that we utilize across our application. Let's go back to the slides. Great. So that is all that I had. Please be sure to fill out feedback. I'd also like to open up the floor to any questions that anyone might have. I think there's mics on each side of the rows.
Cool. My question is, with promotion between environments, how frequently are you releasing actual production software to customers, or is this a separate push for a CD that comes later in here?
That's sort of the next step when we talk about the continuous deployment portion. In this instance, we have gates that actually check and validate through each environment. As the 4 that I mentioned, those are fairly manual once you get past the dev stage. So QA and UAT are checks that are done internally by teams. Now, in the future, the goal is to improve that to at least the point where we have that automated all the way through to UAT. Not quite sure if/when we'll get to the point where that goes to production, considering we primarily have enterprise customers who need some predictability around the way that it gets deployed.
Hi, my name's Matt. What you just described seems to assume that all of the underlying infrastructure is already in place, but do you have similar automation like this around provisioning? So for example, all the stuff gets deployed to a Kubernetes cluster. How does the Kubernetes cluster get there in your shop?
Right, yeah, that's the point. Yeah, so with respect to provisioning the infrastructure, that was the point that I mentioned earlier about deployment manager, how that could be utilized. We're also planning on actually moving that towards an implementation using Terraform to manage that. Which is 100% the recommendation that I would say to provision that infrastructure.
Thanks for sharing the insights. I have a question when you're deploying to production. Like, are you doing any sort of canarying, and how are you doing that? Like, long running, like a couple of pods or something, like, yeah.
In this instance, we just do rolling updates. We have scheduled times where we actually go about and execute those production releases. So we are not currently, and this implementation does not really currently support anything like blue-green or canary deployments. Obviously, that would be recommended as part of a long-term production solution for sure.
I saw that there were some functional tests in the manifest repo. Do you guys do unit testing or functional testing on the Kubernetes objects before you deploy them? Or is there any kind of barrier of entry to
Yes, so in terms of testing, we actually, within the Travis pipeline, that actually handles some testing before that gets built and actually deployed to the environment. There are then tests that actually happen on that environment itself. So multiple different layers that are involved in that cycle.
question. So how do you handle failures that might occur in any stage? So the tests pass and you deploy the new artifact to a stage, but still errors happen. What is your rollback strategy?
In terms of a rollback strategy, I mean, we're essentially relying on the implementation of the health checks that we have in place as part of the Kubernetes deployment updates. We use the rolling updates in order to push those out, and so those health checks are basically our monitor to validate that those pods are actually working as expected.
So the readiness and liveness probes?
Sorry, what is that?
Are you using the readiness and liveness probes of your deployment of the pods?
I'm not sure I understand the question, but maybe we have some extra time if you want to come up and ask me in person. You can do that.
Thanks. So how do you deal with provisioning of databases, schema updates, rollbacks on those as well?
So I didn't really cover that in this instance. Right now, I think a lot of our updates on the database side, most of our updates are fairly manual. I mean, we have scripts that update and handle the provisioning of new environments. We are trying to move that to something a little bit more automated. We're relying mainly on for instance, on the SQL side, Google Cloud SQL, to handle all the updates to infrastructure. But obviously, schema changes or something, that's all handled manually.
Okay, just one clarification. So you mentioned that your infrastructure manifests are in a separate repo compared to your application, right?
That's correct.
So how does, what kind of relationship they have in terms of this deployment process? Are you only depending on the application repo to generate CA artifacts and nothing else?
Yeah, so the application just basically hosted all of the code representing what actually runs those services or that application itself. Then then Travis, or the CI tool, essentially then is what pulls that, builds it into the requisite artifacts, like I said, Docker images or whatever, and host it in the repository.
Okay, thanks.
Okay.
Did you explore Spinnaker for the deployment before you finalized on the deployment manager?
So I didn't catch that.
Did you explore Spinnaker as your deployment tool by any chance as part of the workflow?
One more time, sorry.
Spinnaker.
Oh no, yeah. So we don't utilize Spinnaker in our implementation. We found it's fairly complex to implement, and I think if we had a great need around that, perhaps how we wanted to manage the logic behind like our Canary and Blue-Green releases, we would do that, but we haven't yet decided to implement that.
Okay, thank you.
Sorry, could you elaborate on or dive deeper into the config management, especially you have different access controls on different environments?
Elaborate on what exactly, sorry?
The config managements, like your prod and dev and different configurations, right? And you don't want everybody to see all these configurations, so how do you manage that, especially in the CI/CD process?
Well, the configs are all attached. Again, we have that separation from the source code as well as the pod configuration. There's config secrets and information that's actually stored, in this case, encrypted in JSON values. That is actually, I believe that's pulled from the Travis CI. Is that what you're referring to?
Yes, we are using different tools, but I'm trying to compare, so.
Okay. Hi.
Sorry, one question. How do you handle rollback? Is there any scenario you want to quickly roll back to the previous version?
Yeah, so rollback's independent, I assume, then after it's already been completed.
Yes.
Again, because we have all of the versions already tagged appropriately, all we have to do then is make a new pull request, and that then, specifying the specific version that we want on that particular pod or from the environment level, that can then handle the actual deployment of that older version. All of those containers are again, they're stored in the container repository, so the historical containers are available for immediate deployment if we need to go back to an earlier version.
Okay, all right, thank you.
What are the major pain points that you've seen from the implementation you guys have done so far?
I think there was mention of some features that we hadn't yet been able to implement yet. So things like handling our production releases via like a blue, green, or canary deployment, that's one thing. In the future, we could probably consolidate a lot of our configs in the pod repositories using like a Helm chart or something like that. That's a future state item that we're actually planning on working on soon. Other than that, I mean, we have our scripts built out, and once those were built out, you know, they kind of just become reusable. We can easily update them, and that's the main source of how we handle all of that. There is a lot of scripts that go into that, so I guess building that out was its own task.
Thank you.
So, how are you ensuring like the Docker images are secured enough to go into production? So, are you integrated with any security tools as part of the CI to scan the images?
Integrated with what?
Security tools. Like how to ensure like the Docker image is secured enough with no vulnerabilities that is going into production.
I mean, in this particular implementation, we don't have anything really around that from a tooling perspective. I don't really have any specific recommendations. We've seen a lot of customers have different options for that, but that could easily be integrated as part of one of the steps. I mean, there are certain components that I didn't really talk about. Like we actually utilize a tool called Codacy for static code analysis. That's just another step that's added to the pipeline. So if you wanted to add something to that, it could be easily included.
Okay, thank you.
Did you say that the configuration repo is generated by the CI/CD pipeline, or is that something that the app developer would maintain as well on top of the app code?
So the container repository, that pod repository is updated as by the CI/CD pipeline. Yes.
So it's not something that someone goes out there and
well, there's an initial template that's created by us, and then it has to actually update it and configure it for what each environment's going to need from like either the specific pod container that we need version or any configuration secrets, things of that nature.
Okay. All right. So it's mostly generated.
It's mostly generated, yeah. I mean, once we're done with the initial implementation, that's all generated from there going forward.
Okay. Thank you.
Cool. Well, we still have a decent amount of time. If you want to ask any questions, come up to me directly. That's fine too. I'll be hanging out for a little bit. But thanks for your time, everyone. Be sure to fill out the feedback survey.
Tell me why. 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 Why
Hello and welcome to our session, Deploy Your Next Application to Google Kubernetes Engine. I'm William Dennis, a product manager on Google Kubernetes Engine, and later I'll be joined by Marshall and Kat from FAIR. In today's session, we're going to be covering 3 broad topics. First, we're going to talk about why you might want to use Kubernetes in the first place, and some of the benefits you can expect to realize if you do. Then I'm going to do a demo on deploying an app into Google Kubernetes Engine. And finally, we're going to talk a little bit about how to introduce Kubernetes into your enterprise. All right. So why should you use Kubernetes as your application platform? Well, first and foremost, Kubernetes is a container platform. So you inherit all the benefits of developing with containers. These include things like language and library flexibility. So no longer are you limited to a particular language in your production environment, like a certain version of Java or a certain version of Ruby. And no longer do you have to put up with some 3-year-old release of a library that for some reason is still shipping in your Linux distribution. With containers, the developer is in control of what they want to run and exactly how they want to configure it. You also get isolated dependencies, so you can run multiple containers on a single machine without them interfering with each other. And production and development uniformity. This is one of my favorite features. So your production environment looks very, very close to your development environment. And in fact, if you have a bug in production, you can typically download that container, run it on your developer machine, attached to, say, the staging endpoints, and actually debug the exact code that was running in production. Not only that, but you also get uniformity between the developers on your team. So gone are the days where you have to spend like a whole day configuring some development machine with all the various tools and things that you need. You just install Docker, and you can immediately be building these containers. You can even have someone on the team using a Windows machine, someone using a Linux machine, someone using Mac, all developing and deploying Linux containers, or whatever operating system that you wanted to use. And you get all this with really minimal overhead and complete resource isolation. So in the past, you might have used virtual machines to get some of these benefits. By comparison, containers are very lightweight, both in the execution and the low overhead of the actual image size. So back to Kubernetes. Kubernetes is then a container platform that manages those containers for you. It does things like handling how to schedule and launch the containers on the machines. It'll do things like reboot any containers that crash. It can even continually monitor them with health checks so that it won't route traffic to something that's hung or a replica of your application that, say, is missing its connection to the database. It performs a lot of operations like this, all with the goal of keeping your application up and running without too much help from you. So Kubernetes is a workload level abstraction, and what I mean by that is you describe your workload and it basically has the job of running that for you. So for example, let's say you have a server that you want to run in a distributed way, or you have a database that has a disk attached that needs to follow it around, or maybe you want to have a logging utility that runs on every single node. Or maybe you have a movie that you want to render 1 frame at a time using the cheapest possible compute. These are all different workloads, and these are all things that you can just represent in Kubernetes terms, and it can handle for you. And I believe that Kubernetes sits at the right level of abstraction. It's not super low level in the sense that you're not having to deal with individual machines anymore, but it's not too high level in the sense that it doesn't interfere with what you're trying to do with your application. It kind of sits very cleanly in the middle. And for me, this contrasts to a traditional PaaS, which kind of like merges into the application layer by imposing a lot of restrictions on you, and also even occasionally like even modifying how the code actually runs. With Kubernetes, these layers between the infrastructure, the application platform, and the application itself are very, very clean. And I think that's important because when you're choosing the application platform you want to use, and when you're looking at abstraction layers, you want to prioritize making hard tasks possible over making simple tasks easier. So Kubernetes, instead of focusing on the easiest type of application to deploy, which is typically, say, a stateless application, and making that task easier, it actually focuses on making it possible for you to deploy a really wide range of far more complex deployments. Things like a machine learning batch task or a database that has state. And it can do all this while enabling a lot of really nice cost efficiencies as well. So I mentioned before that containers have really low overhead. When you combine that property of containers with the power of Kubernetes to manage those containers for you, you can actually really pack a whole bunch of containers onto machines. And you can have a bunch of machines running at really high efficiency. And you can even do that in such a way that doesn't compromise the availability and reliability of your services. And this is really something I think that's unique to Kubernetes and one of the real big value adds that Kubernetes brings over just raw containers. Kubernetes also comes with a rich ecosystem and community. So let's say you want to add like some logging or monitoring service to your application. With Kubernetes, you typically have the choice. You can either get some open source and run it yourself, or you can find a vendor that can manage and run that for you. I think this is really good because it kind of lets you pick and choose what you want to focus on. Maybe in some areas, you'd rather have someone else manage it for you. But in others, maybe you actually really want to understand how that's working and you want to run it yourself. With Kubernetes, you always have both options, I find, with pretty much anything that you want to try and do. And of course, Kubernetes itself is open source, and perhaps equally importantly, it's really widely available. How wide? Well, if you look at the Certified Kubernetes program run by the CNCF, the Cloud Native Compute Foundation, you'll see that there are currently 32 platforms that are certified, 54 distributions, and 14 installers. So you really have a wide range of choice of where you want to run that Kubernetes. And of course, Google Kubernetes Engine is a founding member of the Certified Kubernetes program. And certainly, not all Kubernetes platforms are created equal. Kubernetes Engine was one of the very earliest to go to market, the earliest managed Kubernetes product. And we have a lot of really robust automation capabilities, things like cluster autoscaling, which can add compute resources when you need them, and remove them in kind of the quiet periods so you can save some money. We have things like node auto repair, which can monitor various unhealthy conditions in nodes and automatically replace them. And we have node auto upgrade, which allows you to stay up to date with the latest features and security patches without you needing to lift a finger. Together, these three features and more really help automate a lot of the operations for you, and it basically means less 3 a.m. phone calls for you. And perhaps importantly, equally importantly, I think, that the same team that brings AE are actually contribute over 40% to Kubernetes itself. So my team's contributions are the kind of yellow-orange line at the bottom there. And you can see that not only do we contribute 40%, but we've actually really sustained and had a long-term commitment to Kubernetes. This graph goes back nearly 5 years. And what this means for you is that if you hit some bug in Kubernetes or you're having difficulty with something that you just can't figure out, well, I'm pretty sure there's someone on my team who's going to be able to help you with that problem. Probably the person that actually wrote the feature that you're using. And of course, you get all this with the benefits of Google Cloud. So all the benefits that you're hearing about this week and that you will hear about this week, such as our world-class fiber network. You inherit all these benefits on Google Kubernetes Engine from Google Cloud. I really like this network. With this, you're basically getting the benefits of YouTube in a way, right? Like Google built this thing out to handle YouTube, and your little app can run on the exact same fiber network. And we're even deploying undersea cables now. So again, all the benefits of Google Cloud in Kubernetes Engine. And speaking of scale, GKE can definitely handle your scale. So I think this is really important, actually, that when you're designing a new application, that you really want to think about scalability from the start. Unless you're creating some internal-only, like lunch ordering app, I'm sure you want more users and you want more scale. But imagine if at that very moment when everyone's kind of beating down the door trying to get into your product, at that very moment of potential success, your application falls over. That's just terrible. That's just the worst thing. So I believe if you start with GKE, and as long as you follow some good scalability principles, we can be there for you and ready to handle your scale and set you up for success. A great example of such a success is Niantic when they launched Pokemon. You might have heard of this app last year or 2 years ago. And when they launched, they actually had the first day traffic, or the first kind of week traffic, was something in order of 50 times their original projection and 10 times their worst case projection of traffic. We were still able to handle that. And as you may know, the launch was fairly successful. So another thing about Kubernetes is it doesn't have a very strongly opinionated development deployment workflow. So you might think that's a burden in the sense that you do have to actually set up your own deployment workflow. But fortunately, using something like Cloud Run, you can actually get a deployment workflow up pretty quickly. And the real power comes in when you actually need to set up some business logic for your enterprise. This might be something like a vulnerability scanner that you want to run before every deploy to ensure that no vulnerabilities are getting out into the wild. Or perhaps it's just some other admission control that you just want to check some behavior, enforce something to make sure your developers aren't doing the wrong thing. All those kind of custom business logics are possible for you to set up in Kubernetes Engine with your own custom pipeline. And with that, I'd actually like to invite up Marshall and Kat from FAIR, who have a lot to say about Kubernetes.
Hey everyone, my name is Marshall.
And I'm Kat, and we're from FAIR.
Cool. So if you haven't heard of FAIR before, you don't know what it is. FAIR is a new car ownership model. That sounds like really markety, so what does that actually mean? If you download the app, sign up, you can search for a car that fits your needs and your budget. Once you have that car, you can give it back at any time, so there's no time commitment. And the entire thing is a mobile experience. You sign and pay for the car all in the app. If you're interested, check it out in the App Store. So I'm sure a lot of us has gone through the experience of buying a car, and you've probably realized that it's not really a fun experience. It's pretty outdated, it's disjointed, and there's not really automation about it. There's haggling involved, you got to get your own financing, you have to get insurance, and at the end, there's a ton of physical paperwork to sign. Every single part of that process can be its own business, and usually is its own business. FAIR has decided that we're going to try and abstract all that into a single experience. That's what we've done. But unfortunately, that brings a lot of legal, financial, and operational complexities. So kind of from the start, we said, maybe a service-oriented architecture is going to be a good fit for us as we try and build out a business that literally didn't exist. Actually, kind of a funny story with that, like 2 weeks before we launched, we decided we're going to add insurance as a product on that. And we were able to do that because of the way that we had structured our services. But with a lot of services comes complexity, and you need to manage that complexity somehow, and that's kind of where we chose K8, Kubernetes. But how do we actually end up on Kubernetes? We didn't start there. The early FAIR employees, we had experiences at prior companies with past products, and we knew them, so we started with those. And it was working, but it really only solved one part of the deployment process, which is really just, or not process, but solution for API servers, web servers, background job kind of things. It solved those. But our data scientist team, they had really subpar infrastructure. They were coming from a prior company where their training was actually done on a fixed set of VMs and some in-office hardware. So it wasn't flexible and it wasn't scalable. The way they actually did their training is they had to SSH onto a box, pull down their model code, run the training code, and then check back in on it later. So they were actually kind of having to coordinate leasing all of that hardware among themselves in order to get their training done. So when coming to FAIR, they said, okay, we're not going to bring all that baggage with us. We're going to try something new. And they were experimenting with ways of expressing their training using kind of like directed workflows. But they needed something to actually power that system. They needed some infrastructure there. So that's kind of where I came in. I was like, okay, you need this problem solved. Let me go look around, find some things in the solution space. I was looking for something that was relatively simple to use and set up and could give them kind of on-demand capacity. So what they needed to submit their training jobs, we could scale up. And when they didn't have anything to train, we could scale down so we weren't paying cost on that hardware. Pretty quickly, we found Kubernetes. And that was really back in the Kubernetes 1.1, 1.2 days. And took a few weeks. We integrated it with their systems, and we got it working. And it was a huge success. It gave them all the flexibility that they needed. And after a few more weeks, we realized, wait, we're running here for their data science training. We could actually be running all of our workloads on Kubernetes, the API servers, background jobs, et cetera. So we cut everything over. And honestly, our devs were actually a little resistant because their previous past products they were using, honestly, were simpler. But at the end of the day, the ability to actually have all of our workloads running on a single platform with a single set of tooling, that kind of operational simplicity really won out. And we started pretty small and simple, just a couple services, but as we've grown, we're not a Google, but we're running 40 some odd various kind of workloads. And Kubernetes has always been able to run every single one of those for us.
So we've been running Kubernetes for 2 years. What are some of the benefits we've actually seen? Well, workflow customization. So William actually mentioned in his portion of the presentation that Kubernetes has really solid primitives for expressing different workload types. And we were actually able to leverage that to write a lot of tooling to automate and abstract our deployment workflow. So what does that mean? Well, we created these standardized build and release pipelines that simplify how an application goes from source to production. So our developers actually can spin up an entirely new service and put it into production, and our platform team does not have to be involved with the process, which is amazing for someone like me because I don't want to spend all day dealing with a developer and helping them put their app into production, right? So how do we actually do this? Well, it actually assumes a lot of defaults, but we actually give developers the flexibility to override some of the defaults in our pipelines to fit their specific needs. So what a data scientist might actually need to deploy their app is very different from what a regular app developer needs, right? And my point really is that even though our pipeline needs have changed over time, in 2 years, FAIR has grown a lot, Kubernetes has always been underneath, very flexible, and been able to fit our needs. So the next benefit we actually got was it forced us into very good operational patterns. So we don't have any apps that are pets or special snowflakes. And if you're not familiar with the pets versus cattle analogy, I'll spell it out for you very quickly. A pet is that one box that you have in production that you have to give a lot of love, and if it goes down, you're really screwed. A cattle is more the box that you can terminate it, and there's probably another one that's already running, or will come back up very quickly, so you don't have a huge problem if it's down in prod, right? So that's the way that we actually think of our applications. We run our applications to try and be as stateless as possible. And the reason for that is because Kubernetes can terminate your workload at any time and actually shift it onto another node. So, for example, your node might actually be suffering from something critical, like it might have very high disk utilization or high CPU utilization. So it might actually terminate your app and then move it onto another node. So as a result, the way that we think about our applications, it's stateless. We try and run multiple replicas of them, and most of our apps actually need to be resilient to running multiple versions at a time because Kubernetes does rolling deployments. One other really awesome benefit we got out of Kubernetes was standardized application visibility. So with Kubernetes, you can see all of your app logs, all of your app metrics. They're all in one place. And on top of that, you can see what apps are actually deployed in a cluster. So with all of that, we actually got some really cool hidden benefits out of Kubernetes as well. We actually migrated our entire workload into another cloud onto GKE without any trouble. So it comes to my next point, and the long list of things you're probably considering, when you're thinking about adopting Kubernetes is whether or not to go managed or unmanaged. We're at a Google conference, so really, GKE or unmanaged, right? So we actually started on AWS in 2016, and we actually didn't have any managed options on AWS. EKS, which is Amazon's equivalent of GKE, didn't come out until late 2017. So we actually opted to run unmanaged because that was the only choice. And we've been running it for 2 years, and we've learned a lot about Kubernetes. So we've developed a lot of really good in-house expertise on Kubernetes, but also after 2 years, we realized, it's actually a full-time job to run your machines. It's a lot of security patches, upgrading your machines, and I know that, for a lot of people in ops, you're kind of worried about going, you want to go unmanaged because you don't want to lose operational control. I'm just going to say, take it from us. We've been doing this for 2 years, And when we migrated our workloads to GKE, we didn't necessarily feel like we were, trading off or giving up a lot of control. And more importantly, like Kubernetes is such a great abstraction on top of cloud providers that we transitioned and moved all of our apps from AWS to GKE, and we didn't have to make any application changes. But speaking of apps and deployments, William's going to come back on stage, and he's actually going to demo how to deploy your app into Kubernetes.
All right, so before I get started with the demo, I just wanted to quickly cover a few key Kubernetes concepts so that some of the stuff in the demo will make sense, just if you're new to Kubernetes. So we'll start with containers. Kubernetes actually wraps containers up into what's called a pod. So a pod is, for Kubernetes, the smallest schedulable unit, meaning that these containers get deployed together. So maybe you'll have like just one container in a pod, or maybe you have multiple in the case you have like a sidecar container that adds like logging or monitoring or something like that. So that's a pod. Then we have a concept called nodes. Nodes are really just a fancy way of saying a machine, which is either a VM or bare metal. And the real workhorse in Kubernetes is a concept called a deployment. And Kubernetes works on this kind of operator pattern where you specify how many pods you want in the deployment. So you say like, I want 2 of pod A and 1 of pod B. And then Kubernetes has this operator pattern that then seeks to drive the actual observed state in the cluster to be the required state that you specified. So that looks like something like this. So say we have a system and we have 2 of pod A, 1 of pod B. And then if one of those nodes were to become unhealthy and disappear, the system would very quickly notice, oh, wait a minute, there's only like 1 of pod A running now and none of pod B. It's going to then reschedule those onto another node, at which time it will then observe that the desired state has been met and everything is right in the world again. So that all happens automatically. That's kind of one of the very nice things about Kubernetes. And that operator pattern applies to various other constructs as well. Lastly, we have a service. And so a service is just a group of identical pods that together kind of provide like a logical, like API service. All right, and with that, I'm going to go to the demo. OK, so I was going to do like a fairly boring Hello World app, but I decided on Friday, actually, to make something a little bit more interesting. So I wrote a little server in Swift, and this server is actually using this other little project at Google called PlusCodes to convert a geographical coordinate into a plus code. Anyway, that's what the app's going to do. I picked Swift because I don't think Swift is really used a whole lot in production yet, and I kind of wanted to emphasize one of those points earlier, that with containers, you really get a lot of flexibility. Like, I love Swift, but personally, I've really just not seen too much of it in production. So if you do want to use Swift in production, I dare say that GK is a good place for you to do it. All right, so what does this little app do? This little app, it's using a library called Swifter. I'm just going to start like a basic HTTP server, handle one endpoint. We're going to parse a couple of parameters. We're going to convert a latitudinal, longitudinal coordinate into a plus code. And then we're going to return that as JSON. Well, let's just take a quick look at what that code looks like. I'm going to build that container real quick. And since it's actually cached, it should hopefully be fairly fast. All right, and let me run that locally. And so I'm going to forward port 8080 on my machine to port 80 in the container there. Let me show you what that looks like. All right, so this is the little endpoint, and that's using my example data. So to prove to you that this is real, let me pull up an actual latitude and longitude to throw in there. Let's look at the Moscone Center. And I'm just going to use Wikipedia for this. Just a good source of geographical coordinates. So let me grab those, whack it in here. And then this is the plus code for the Moscone Center. So if you have Google Maps, you can type this into Google Maps and you can find where we are. And one of the cool things about this is you can actually drop off the first 4 digits if you're in the same region. Okay, so anyway, that's my Swift app running in a container, running locally. Let's get it up onto Kubernetes. So on Kubernetes, on GKE, you can create a cluster just with a few clicks. I'll show you what that looks like. You just tap that Create Cluster button. And then we have a whole list of templates that you can pick from. So just pick the one that matches your workload the best. So say for this demo, frankly speaking, this little Your First cluster would probably be quite sufficient. I can leave all that as default, click Create. Now, since that might take a couple of minutes to come up, I'm just going to use this one that I created earlier, which is Next Demo. So let's take a look at that cluster. OK, and I can click the Deploy button. And it's going to ask me for a container image. So let's go back to the console. And I'm going to tag that image. And this is using a special tag for Google Container Registry, which is gcr.io, and then my project name, and then my application name. So I'm going to push that up. And of course, looks like my cache is gone, so we're going to test how good my wide connection is to upload a gigabyte of data. While we're waiting for that to happen, let me just show you a couple of things here. So Kubernetes, we show you the workloads and the services and any applications you're running, all in the UI, which I think is something that maybe isn't available on other platforms yet. So for example, you can go in, look at the services that are running. Let's see how that's going. All right, about halfway done. OK, so while we're waiting for that to upload, let me queue up some changes. So after I've deployed that, one thing I'm going to show you is also how to do an update. So the first update I'm going to do is I'm going to just make a very small change in this little service. Let's add like a status field, like this one. So let me queue that up while we're waiting. All right, sorry about this. I did this demo like 30 minutes ago, and it took like 10 seconds to upload. So, of course, what can I expect? I think we're almost done. Who knew Swift was such a large language? All right, looks like we are good. OK, so I'll go back to that deployment that I was creating, and I'm going to pick that image that I just pushed to Google Container Registry. I can leave the command as default, because it's just going to pick up the command from the Docker file. I'm going to give that a name. I'm going to pick my cluster, which is going to be that demo cluster, and just hit deploy. So this has now created a Kubernetes deployment all via the UI. I can also take a look from the command line and see how that deployment is. So I do this kubectl get pods, which is basically doing the same thing, but on the command line, just inspecting the state of those pods. And we can see that already we have 3 pods running with that container. So you can see just how fast that is. Now, the next thing I'll need to do here is expose this as a service. So I'm going to go expose. I'm going to leave that as port 80, because that's my service. Pick a load balancer so we can access it from the internet, and click expose. Now, that action will take about 30 seconds to complete, because it's actually provisioning a Google Anycast IP, or one of various points of presence around the world. So to save time there, I've actually prepared that one earlier. So we'll go to the Services tab here, and we can see this service that I created earlier, and just take a look at that. And so that is now the same application, but running in Google Kubernetes Engine. Let me pick another coordinate to try out, just so you know I'm not faking it. Let's look at, say, the Golden Gate Bridge. Use the Wikipedia again. Grab that latitudinal, longitudinal coordinate. OK. And I said I would also demonstrate an update, so let's go back to the console We'll build the container again, this time tag it as version 2. Fortunately, this one should be quick to upload. Sorry, I need to actually build that. Okay, build it first. And while we're waiting for that, let me go back into our deployment view here, and I'll show you how to update. So I can just go into the deployment I created, and I can use this update action here, rolling update, and I'll specify that same image tag that I just created. And I can also customize just how quickly I want this thing to roll out. So by default, when Kubernetes does a rolling update, it will one by one replace the pods in the deployment, and it will do it in such a way that there's no downtime. If I really want that to go out quickly, I can kind of just say, you know what, I just want everything to go out at once, so we can try that here. Okay, so now that container's built, let me push it up, and then I'll hit the update button. All right. One really nice thing about Kubernetes is even if I click that update button before the container was ready, it will actually handle that condition. So it would actually try and pull that image, it would notice that it wasn't present, and it would try again a few seconds later. And that's all part of that operator pattern I was saying where Kubernetes is driving the desired state it's driving the observed state towards your desired state. All right, and if I go back in here, I should now see we have a new version of the application running just a few seconds ago. Valid image name, okay. That would be the reason. Okay, and looking at the UI view here, we see that revision 3 of my deployment is currently in the container creating state, so very shortly that will be available for use. I can inspect the same thing on the console, and looks like it might actually be running. Okay, so let's go back to our example, refresh that, and you see we have that status. Okay, so that's how to deploy and then update your application in Google Kubernetes Engine. I'm going to show one more thing real quick, and that is how to set up a cloud build continuous integration pipeline. So let's go to cloud build, and let's also open up the source repositories. So what I'm going to do is I'm going to push my application up to the Git repository in the cloud, and I'm then going to use a continuous integration process to build that container. So first thing, I'll create the Git repo, and I'll call that pluscode. We'll go back to the app. I'm going to make one more change just so we can observe that change. Let's say the status is now awesome. And thank you for laughing. All right, let's commit that. Well, actually, before I push, let me create a build trigger. So now I'll go into cloud build, into the triggers. And I'm going to add a trigger so that anytime code is pushed to that repository I just created, it's going to build the image, the container image in that repository. So I can actually leave this all as the default, and it will actually build my Docker image for me. Okay, so now let me push that up. And if we go into the history here, we'll see that a build has just kicked off. And again, this is going to take a minute, but one nice thing is I already know what the image name is, so I can grab that, and I can do the rolling update right now, even before it's ready. So I'm just putting in the image name here from cloud build. And in this case, I'm going to say I want a max unavailable of 0. So I don't want Kubernetes to take down any containers until the new one is ready. I will do a surge of 3 though, because I think there's enough capacity to handle that. All right, so 2 things are happening here. Kubernetes is actually waiting for that container to appear, and we're waiting for that container to finish building. Looks like it is underway. All right, well, I think we've waited enough for me to upload things. So if you really want, you can grab that IP and check it out later, and you should see my deployment from Cloud Build. With that, I'll go back to the slides, please. All right, so one final word about Plus Codes. If you thought that was interesting technology, take a look at plus.codes. This is a little project that a bunch of Googlers work on in their 20% time. I think it's pretty cool. There's also video to check out. And I'll be putting the code that I used in the demo online later as well. That will be the link at the bottom there where I'll upload it. It's not actually available quite yet, but I'll make sure that's up by the end of the week. Okay, so what are the next steps? So now that we've got our application deployed into Kubernetes via the UI, there's certainly a lot of things that you might want to do before you're ready to hit the go to prod button on that. The first one to consider would be readiness and liveness checks. So these are probes that you can configure in Kubernetes, where Kubernetes continuously probes your container to ensure that it's actually still running and ready to serve traffic. Then I think you'll want to look at requests and limits. This is specifying the resources that your container will need. Requests relate to how much resources get reserved when your container is scheduled, and limits is the maximum of those resources that your container can use. So when your limits are greater than your requests, it means that your container can actually use any unutilized resources on that node. Thirdly, I'd recommend looking at configuration as code. So you saw me just deploying things and updating things via the UI, which is a really great way to get started and learn Kubernetes. But eventually, you want to get that configuration, you want to download it into your version control, and treat it just like source code. So have any configuration changes go through code review, and any kind of security process you have with your source code. And through that, you'll also gain the ability to roll back. So if you released a version by changing the configuration through Git, you then realize it was a mistake, well, you can just do a Git revert, and your configuration would revert, and Kubernetes will update. Finally, I would recommend looking at auto-scaling. So GKE, in particular, has a really good auto-scaling technology. I actually demoed one last year at Next, and I've put the link up here for you if you're interested to see it. You can actually set up a requests per second based pod autoscaler, which is really kind of cool stuff. Basically, it lets you say, for every 100 simultaneous requests per second that I'm getting, I want to have like 1 pod backing that. So if you get 1,000, I want 10 pods. That is something that you can just basically state in like 3 lines of configuration, and Google Kubernetes Engine will make that happen for you. All right, so with that, I'd like to invite Kat and Marshall back up on stage, where we're going to have a bit of a conversation about rolling out Kubernetes to your enterprise. Kat and Marshall. Thanks. So one thing we realized as we were preparing for this talk is your experience with Kubernetes is kind of, I guess, fairly similar to some other customers I've spoken to, particularly the way that you actually deploy Kubernetes into your organization. So I thought it might be interesting to just have the audience hear from you sort of how you introduced Kubernetes to your org.
Well, so in terms of like introducing Kubernetes into your organization and how quickly you should do it, I would say very slowly, like glacially slowly. Especially if you have a lot of workloads that are already in production that aren't on Kubernetes. For us, we had the benefit of being able to start on Kubernetes, but I think for most companies, Kubernetes is a huge thing to bite into, I guess. And so probably the best thing to do is to cut over non-critical, maybe new apps into your Kubernetes cluster and start developing in-house expertise before you go whole hog into it.
Yeah, also, we had basically a year to develop in private and, more importantly, fail a lot in private. So that was sort of why we were able to start with it. But as Kat said, start slowly with kind of non-critical things, because it's easy to make mistakes. like that demo showed, where you roll out your change and you've got the image wrong and you didn't set any safety, and suddenly your application is entirely down.
And so readiness checks for that one, right?
Yeah, readiness checks.
And I'm kind of curious to learn, like, what average level of Kubernetes knowledge does the developer have? So, like, for example, does the typical application developer need to know about services and deployments and YAML files and things like that in their daily job?
Yeah, I think for us, most developers are kind of at an observability point of their knowledge. They still are doing some configuration at sort of the deployment and service level, but it's pretty standardized in terms of like, that's all they need to know. There's a whole bunch of other abstractions that Kubernetes provides that they don't really need to. So I think we have some power users, obviously, who are doing, I think our data science team, honestly, is on the further side of that power user side, and they're doing a lot of interesting stuff, and they really are in the weeds. But for most people, it's just like, let the pipeline take care of it, and then use, kubectl to see, what does that actually look like? What's your state of your deployments?
Yeah, I remember when you said that, like, I really kind of like that setup where if I'm a developer, I can kind of not use any of the Kubernetes if I don't want to, and just focus on my container. Or if I really need to understand how things are working under the hood, I have that level of access as well. And I think that kind of, to me at least, contrasts to a PaaS, where you sort of can't get access to that lower layer, right? Yeah. And so we talked about failure. What tips do you have for making your workloads more resilient?
We actually set anti-affinity policies. So that basically means telling Kubernetes, hey, I actually want to schedule pods of one deployment onto different nodes. This is actually one of those moments where it's like, yes, you should actually fail privately, spend some time like really learning Kubernetes, because this was something that we weren't really aware of, and we actually, it became like a war story in the sense that, oops, we screwed this up. We were actually rolling over a cluster, bringing in new machines, and this happens very rarely, but we had all of the pods of one deployment on one machine, and when that machine was drained and it was taken down, we accidentally took down that entire deployment and service.
So basically with Kubernetes, if you don't actually specify how you want your pods kind of spread out, you could be very unlucky and have them all land on one node. So that's kind of a...
I mean, yeah, it'll just do a best guess and try and fit where it can, which is great in terms of, filling up your VMs as best as possible. But unless you give it those hints, it's like, I'll put them all on one place.
And so since you set up the anti-affinity, how's it working?
Anti-affinitively?
And I'm kind of interested in your journey, particularly the sense that you started unmanaged. Did you want to elaborate any more about that?
Yeah, sure. I mean, obviously, as Kat said, we started on AWS, and there weren't options for us there. But it wasn't necessarily impossible for us to run it ourselves, so we said, cool, let's go do it. But it wasn't really easy either, and speaking very frankly, it's basically just the two of us who have that institutional expertise, and we're not seeing the benefits that we really, well, we're not seeing benefits from having us just run it. We're not giving, like she said, we're not giving up control if we go with, a managed offering. So that's really where, like, keeping up with the pace of Kubernetes, really, because, like, there's features coming in all the time, and, like, we want to be able to take advantage of those features, but then if it's like, we got to do those Kubernetes version upgrades and version rollouts, and that's just more burden that we have to take on.
And just one additional point to that, I think I was trying to test out Istio, and it probably took a week to get it functioning just right. We do have like kind of a bespoke multi-cluster setup, so it took a little more time to like tweak everything to make it work. But on GK, it's a one-click deploy, so that was really cool to find out after the fact.
All right, and the last question from me before we throw it open to you all. Tell me about preemptables. So preemptables, if you're not aware, it's this machine type that isn't guaranteed to even be available and can kind of be preempted and reclaimed with like 30 seconds notice. But you mentioned in our prep that you're actually using them, so I'm kind of curious to learn more.
Yeah, for actually all of our non-production environments and our data science clusters, we actually use preemptibles. For data science, it's actually a great advantage because we're actually spending cents on the dollar for those very, very beefy machine workloads. And then all of our staging and sandbox environments are using preemptibles. And there's actually like a really funny story like associated with it because preemptibles are called preemptibles for a reason. And this happens very rarely, but in the 2 years that we've been running with preemptibles in this setup, we actually on a weekend once got a ping from a developer who was like, "Hey, I don't see any pods in staging. Is it down?" And so we're like, "Oh no, what's going on?" We like jump in. You do kubectl get pods, you see nothing, and you're like, "Okay." Kubectl get nodes, you also see nothing, and you're like, "Okay, cool, what's going on?" And then it turns out that there were none of the instances left to like bid on for those preemptibles, and so we just kind of changed VM types, and then staging came back up in 5 minutes. But that is the risk that you incur, doing preemptibles. So don't do that in production. For staging, it's fine.
Yeah, I think any discussion of preemptibles has to come with that disclaimer. Don't do it in production. But it's interesting because you have like non-production workloads that are still kind of very important to the business, like machine learning even, that just don't necessarily need to, I guess, complete by a certain time. Is that?
Yeah, and I mean, I think especially with those ones, it's important to remember that, like as she said, once we had changed the instance type, and our nodes were able to come back in, Kubernetes was just like, oh, this state of the world is not in the desired state, so I need to put it back in a desired state. Right. So like with machine learning and the training models they were doing there, if the nodes just went away and then eventually they came back, it'd be like, oh, there's still workloads I need to finish, and then it would go and like make them happen. So that was kind of a like pseudo disaster recovery kind of scenario.
Yeah, I definitely think like using preemptibles without Kubernetes would be really, really hard. You would basically have to you basically build Kubernetes, I think. So anyway, cool. Well, with that, that's the end of our prepared content, but it looks like we have about 3 minutes if you have any questions. And there's also been a Dory, so I believe if there's any Dory questions, we'll have those now as well. But thank you everyone for joining us today. Oh, yeah, there are 2 mics near the front here, so if you have any questions, please come up. We have about 3 minutes.
Yeah, the question is that whenever we are running stateless, it's absolutely fine. But when you try to write something persistent, like say you are using Elasticsearch or Redis.
Sorry, we can't quite hear you.
Okay, so say you are running something which is stateful, not stateless, not like a microservices container. Say you are running Elasticsearch or you're running Redis or something like that, then how do you manage that if the scheduler is killing the node?
Right. You want me to cover that?
I think at least from our point of view, and this is mostly as a side effect of the fact that we've been running the clusters ourselves for a long time, is we've sort of abused that fact and said, great, we're not running stateful stuff, so we can roll our clusters at any time and it's no big deal. But moving to a more managed system like GKE, actually, I think there's a lot more stability there, and there are primitives like stateful sets and other things that will actually allow you to do exactly what you're talking about. It's just a side effect of our own history that we've sort of shied away from that.
Yeah, so definitely stateful set is what I recommend looking into. It's basically an entire kind of workload abstraction designed exactly for something like Elasticsearch. And in fact, if you are using something like Elasticsearch that has kind of a known deployment pattern, you may even be able to use like a prepackaged operator to basically do that for you. So anytime you're using kind of like off-the-shelf software, look for a prepackaged, what's called an operator, and you may even have to do even less than set up a stateful set. Like it will do that for you as well. So,
yeah, because of the networking, it's a real challenge when you try to load something which is doing multicasting at that level. So at the v4 level. Okay, thank you very much. Yeah.
Cool, thank you.
Yeah, I was just curious, when you made the decision to use a managed solution, what were your thoughts or concerns about cloud portability and moving away from that?
It's actually kind of funny because we were worried about cloud portability because we rely on a lot of AWS services. But what's actually interesting is that while cutting over to GKE, the only thing we really needed was the EC2 metadata service. And you can actually write some abstractions around that. And once we achieved that, we could actually run all of our workloads just fine on GKE.
Sorry, one follow-up. If you had to move away, do you feel like you would have issues spinning up that Istio service mesh in a non-managed solution?
Spinning up Istio in a non-managed?
So if you were to leave GKE without that nice kind of click to deploy Istio.
Oh, I already went through that. It was rough.
She could go back. She wouldn't want to go back, but she could.
If I could add one thing to that, I think by Google Kubernetes Engine doing the management for you, like your actual application is still deployed, speaking to Kubernetes APIs. And so your application is no less portable running on a managed service, would be my take on that. That you could then go back to unmanaged, and your application should be able to port right over. And incidentally, like, my team wants that portability for you. We actually don't want people locked in because they're in some proprietary API. We want to give people the best experience possible and have them use us because they want to be on GKE. That's very much our philosophy.
Yeah, and even one more point on that, really all of our apps aren't really interacting with Kubernetes. They're just deployed on Kubernetes. So they're just relying on things like DNS and having disks available and things like that, which you could replicate in another system, but it's just a bunch of work.
All right, and I think we're actually over time, so maybe we can take like one more question. Sorry.
I'm just wondering whether you guys have had the need to impose different kind of hardware requirements on different kind of workload. For example, sometimes you need a workload that need to run GPU. Other times you need large memories. If yes, can you comment on your experience with using Kubernetes to achieve that?
Yeah, sure. So we have sort of two examples. I think our data science ones, they're using much beefier machines, and we actually just gave them their own cluster. So in that sense, we're not really choosing, but we definitely could. And another example is we have some kind of network layouts, and we've marked those nodes as having certain properties, and so we're able to schedule apps onto the ones that have certain kind of security features in terms of their firewalls and such. So it's pretty flexible, and it's kind of like if you needed to mark nodes as having certain hardware features and then schedule onto them, it's super simple.
And yes, everything runs within one cluster.
Yeah, so you can use taints and tolerations to achieve that as well. So you can have like those beefy like GPU machines can be tainted with a particular mark that says this machine has a GPU, and then that way only a workload that wants that will actually use it. So then you can avoid kind of like your cheaper like batch jobs taking up GPU dies. Thanks for the question. If anyone had more questions, we'll be outside in the hallway for like another 15 minutes, so please join us. Thanks again.
you up when you think you're alone, and no one picks up the phone. Forgotten skin and bones. Oh, yeah, I take you home, fill your body with chrome, build a castle to hold. 'Cause you build me up, oh, 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 and you never let go. Oh, 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 yeah, you build me up, oh, 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 and you never let go.
So welcome everyone to our session on next generation CI/CD with GKE and Tekton. So I'm Kim Lewandowski and I'm a product manager at Google.
And hey everybody, I'm Christy Wilson. I'm also from Google Cloud and I'm an engineering lead on Tekton.
So before we get started, a quick show of hands. How many of you are running Kubernetes workloads today? Wow, quite a few, awesome. And how many of you are practicing CI/CD? Okay, awesome. And then using Jenkins? Nice. Something else? Okay, cool, good mix. So today we're going to cover some basics. We're going to talk about a new project called Tekton that we've been working on. We're excited. We have 2 guest speakers joining us today to talk about their integrations with Tekton. We're going to briefly cover Tekton governance, and then finally, what's in the pipeline for us.
So we're here to talk to you about the next generation of CI/CD. And we think that the key to taking a huge leap forward with CI/CD is cloud-native technology. So I, for one, found myself using this term cloud-native all the time, but I realized that I didn't actually know what it meant. So this is specifically what cloud-native means. Applications that are cloud-native are open source. Their architecture is microservices in containers, as opposed to monolithic apps on VMs. Those containers are dynamically orchestrated, and we optimize resource utilization and scale as needed. The key to all of this is containers. Containers have really changed the way that we distribute software. So instead of building system-specific binaries and then installing those and installing a web of dependencies, we can package up the binaries with all of their dependencies and configuration that they need and then distribute that. But what do you do if you have a lot of containers? That's where Kubernetes comes in. So Kubernetes is a platform for dynamically orchestrating containers. You can tell it how to run your container, what other services it needs, what storage it needs, and Kubernetes takes care of the rest. And then in addition to that, Kubernetes abstracts away the underlying hardware. So you get functionality like if a machine that's running your container goes down, it'll be automatically rescheduled to a machine that's up. And in Google Cloud, we have a hosted offering of Kubernetes called Google Kubernetes Engine, or GKE. So this is what cloud native ends up looking like for most of us. We use containers as our most basic building block, then we dynamically orchestrate those containers with Kubernetes and control our resource utilization. And these are the technologies that we're using to build cloud-native CI/CD.
Cool. So for those not familiar with CI/CD, and it sounds like most of you are, it's really a set of practices to get your code built, tested, and deployed. So CI pipelines are usually kicked off after a pre-submit workflow and determine what code can be merged into a branch. And then there's CD, which is what code changes you then deploy to a branch either automatically or manually. And so what we've learned is that there's not really a one-size-fits-all solution. There are projects that just want something simple and just something that works out of the box. And then there are companies with really complex requirements and processes that they must follow as their code travels from source to production. So it's an exciting time for us in this new cloud-native world for CI/CD. So CI/CD systems are really going through a transformation. CI systems can now be centered around containers, and we can dynamically orchestrate those containers, and using serverless methodologies control our resource costs. And with well-defined conformant APIs, we can take advantage of that power and not be locked in. But in this new world, there's a lot of room for improvement. Problems that existed before are still true today. And some are just downright harder. If we break our services into microservices, they inherently consist of more pieces, have more dependencies, and can be difficult to manage. And the terminology is all over the place. The same words can mean different things depending on the tool. And there are a lot of tools. It seems like every week a new tool is announced. So I can't even keep up with all of them, and I know that our customers are having challenges making their own tooling decisions. So it's great to have this many choices, but it can often lead to fragmentation, confusion, and complexity. But when you squint at all these continuous delivery foundation or solutions, at their core, they all start to look the same. They have a concept of source code access, artifacts, build results, etc. But the end goal is always the same: get my code from source to production as quickly and securely as possible. So at Google, we took a step back, and after a few brainstorming sessions, we asked ourselves if we could do the same thing to CI/CD that Kubernetes did with containers. That is, could we collaborate with industry leaders in the open to define a common set of components and guidelines for CI/CD systems to build, test, and deploy code anywhere? And that is what the Tekton project is all about. Tekton is a shared set of open source cloud-native building blocks for CI/CD systems. Even though Tekton runs on Kubernetes, the goal is to target any platform, any language, and any framework, whether that's GKE, on-prem, multi-cloud, hybrid cloud, tribrid cloud, you name it. So Tekton started as a project within Knative. People got very excited to be able to build images on Kubernetes, but very quickly they wanted to do more. They wanted to run tests on those images, and they wanted to define more complex pipelines. And as enthusiasm grew, we decided to move it out and put it into its own GitHub org, and where it became Tekton. So again, the vision of this project is CI/CD building blocks that are composable, declarative, and reproducible. We want to make it super easy and fast to build custom extensible layers on top of these building blocks. So engineers can take an entire CI/CD pipeline and run it against their own infrastructure, or they can take pieces of that pipeline and run it in isolation. And the more vendors that support Tekton, the more choices users will have. And they'll be able to plug and play different pieces from multiple vendors with the same pipeline definition underneath. So Tekton is a collaborative effort, and we're already working on this project with companies including CloudBees, Red Hat, and IBM. And we made a super big effort to make it easy for new contributors to join us. And again, pipelines is our first building block for Tekton, and now Christy will be diving deeper.
So Tekton Pipelines is all about cloud-native components for defining CI/CD pipelines. So I'm going to go into a bit of detail about how it works and how it's implemented. So the first thing to understand is that it's implemented using Kubernetes CRDs. So CRD stands for Custom Resource Definition, and it's a way of extending Kubernetes itself. So out of the box, Kubernetes comes with resources like pods, deployments, and services, but through CRDs, you can define your own resources, and then you create binaries called controllers that act on those resources. So what CRDs have we added for Tekton Pipelines? Our most basic building block is something we call a step. So this is actually a Kubernetes container spec, which is an existing type. A container spec lets you specify an image and everything you need to run it, like what environment variables to use, what arguments, what volumes, etc. And the first new type we added is called a task. So a task lets you combine steps. You define a sequence of steps which run in sequential order on the same Kubernetes node. Our next new type is called a pipeline. A pipeline lets you combine tasks together. And you can define the order that these tasks run in. So that can be sequentially, it can be concurrently, or you can create complicated graphs. The tasks aren't guaranteed to execute on the same node, but through the pipeline, you can take the outputs from one task and you can pass them as inputs to the next task. So being able to define these more complex graphs will really speed up your pipelines. So for example, in this pipeline, we can get some of the faster activities out of the way in parallel first, like linting and running unit tests. Next, as we run into some of the slower steps, like running integration tests, we can do some of our other slower activities, like building images and setting up the test environment for our end-to-end tests. So tasks and pipelines are types you define once and you use again and again. To actually invoke those, you use pipeline runs and task runs, which are our next new types. So these actually invoke the pipelines and tasks, but to do that, you need runtime information, like what image registry should I use, what Git repo should I be running against, and to do that, you use our fifth and final type, pipeline resources. So altogether, we added 5 CRDs. We have tasks, which are made up of steps. We have pipelines, which are made up of tasks. Then we invoke those using task runs and pipeline runs. And finally, we provide runtime information with pipeline resources. And decoupling this runtime information gives us a lot of power, because suddenly you can take the same pipeline that you use to push to production, and you can safely run it against your pull requests. Or you can shift even further left, and suddenly your contributors can run that same pipeline against their own infrastructure. So this is what the architecture looks like at a very high level. So users interact with Kubernetes to create pipelines and tasks, which are stored in Kubernetes itself. And then when the user wants to run them, the user creates the runs, which are picked up by a controller, which is managed by Kubernetes, and the controller realizes them by creating the appropriate pods and container instances.
Cool, so today I'm excited to welcome engineers from CloudBees and TriggerMesh to talk about how they've been integrating with the Tekton project. And I want to highlight that they were able to do this very quickly because we put a ton of time and effort into onboarding new collaborators. So first I'd like to introduce Andrew Bayer on stage to talk to us about JenkinsX and how JenkinsX is integrating with Tekton.
Sorry about that. Mic juggling is, always a pain. Hi, I'm Andrew Bayer. I'm an engineer at CloudBees working on pipelines both in Jenkins and JenkinsX. So, who here's heard of JenkinsX? That's a lot of people. Who here's played with it or is using it, et cetera? All right, it's good. So, in case you're not familiar with JenkinsX, let me try and probably fail to explain it very well and then get corrected. JenkinsX is a new CI/CD experience for Kubernetes. It's designed to run on Kubernetes and target Kubernetes. You can use it for building traditional and cloud-native workloads. You can create new applications or import existing applications into Kubernetes and take advantage of various quick starts and build packs that allow you to get the initial setup of the project, et cetera, without having to do it all by hand. Gives you fully automated CI/CD integrating with GitHub via Prow, so a lot of automation and GitOps promotions, et cetera, without you actually having to go click stuff by hand. It's got promotions, it's got staging, dev and prod environment integration, and a whole lot of other magic. I'm here specifically to talk about the part about how JenkinsX is using Tekton pipeline. So a user is not actually going to necessarily know that they're using Tekton pipelines behind the scenes. We have our own ways of defining your pipelines in JenkinsX, either via a standard build pack or when you define your own pipeline using our YAML syntax. Then at runtime, when a build gets kicked off, JenkinsX translates that pipeline into the CRDs that are necessary to run a Tekton pipeline. And then JenkinsX monitors the pipeline execution, et cetera. So that means that, like I said, the user isn't directly interacting with Tekton. The user's interacting with JenkinsX. That means that we can do a lot of things on our side without having to worry about exactly how the user's going to interact. So why are we using Tekton pipelines? Like I said, I've been working on Jenkins pipelines as well for a while now, and what we've come to learn is that pipeline execution really should be standardized and commoditized. CI/CD tools all over the place have reinvented the wheel many times, and there's no reason for us to keep doing that. So I'm really excited about that. And we really like that we can translate our syntax into what's necessary for the pipelines to actually execute, so that we're still able to provide an opinionated and curated experience for JenkinsX users and pipeline authors. without having them to worry about being exactly the right syntax and verbosity, et cetera. And it gets us away from the traditional Jenkins world of a long-running JVM controlling all execution, which is, good. But the best part is, as Kim mentioned, how great it is to contribute and get involved with Tecton pipelines. I only got involved with this at all starting in November, and we've been able to contribute significantly to the project, help with the figuring out direction, fixing bugs, integrating it with JenkinsX, and get this all to the point of being pretty much production ready in just a few months. And that's phenomenal. It's just been a great experience, an incredibly welcoming community, and just been a lot of fun. I don't have an actual demo exactly. Let me go back again. Sorry. Oh, and of course my screen went to sleep. Hold on. Typo. All right, so what I wanted to show you here was just quickly how much of a difference there is between the syntax a user is authoring and what Tecton actually needs to run, and why we think that's valuable. So this is roughly what a obviously brain-dead simple pipeline in JenkinsX would look like. Just 26 lines. And then when we transform it, well, it's a lot more than that. But because we're able to generate that and not require the user to author it all by hand, we're able to inject JenkinsX's opinions about environment variables, about what images should be used, and a lot more. And it's been really great for us to be able to have the full power of Tecton pipelines behind the scenes during execution without needing to make the user have to worry about all of those details all the time. So that's been really productive for us. So thank you.
So next, I'd like to introduce Chris from TriggerMesh to talk about the work he's been doing.
Oh, cool. Actually, yeah. So thank you, Kim. Thanks, Andrew. Hi, everyone. My name's Chris Bombauer, developer with TriggerMesh, and also one of the co-authors for TriggerMesh's Action. Oh, wait. Let's try. Okay, cool. Okay, so starting off with TriggerMesh's Action, this came out as more of a way of tying in the GitHub Actions, the GitHub Action workflow once it was announced last October into creating a way of being able to bind that with the Tecton pipeline approach. The idea being that with that workflow, we can translate that into the various resources that the Tecton pipeline now makes available, and then be able to feed that into your Kubernetes cluster and be able to either experiment with it or even create additional hooks so that it can actually receive external stimuli through something like Knative's eventing service. Things such as like whether it is going to be a pull request from something like GitHub, or maybe it is some other web form being filled out that triggers that build or that workflow in the background to provide the result, and ultimately allowing you to run things from anywhere. So a little bit of a mapping exercise for the terminology goes. With GitHub Actions, you have the concept of the workflow. The workflow, it would be like the equivalent of the Tecton pipeline's global pipeline. This is where anything and everything runs task-wise. And then as far as the GitHub Action, that is the equivalent of that single step or that task where it's going to be that one container that runs that command that produces the output. And I do call out one of the other components within the GitHub action, which is called uses. This is more of being able to define the image that you want to run within your Tekton pipeline task. Whereas with the Tekton pipeline tasks, expect a particular image. What we end up translating with the GitHub actions, or at least we will once I finish my pull request, is that we'll be able to allow the full support that GitHub has for their actions, as far as being able to point it to another GitHub repo or point it to some other local directory within that repo that you have defined, to be able to build the Docker image that you can then feed into the task to work the magic, as it were. So as far as our little pretty picture, with the trigger mesh action, we actually have 2 commands that handle everything. We have down at the bottom the create. This one creates the tasks, creates the associated pipeline resources, and you can also use it to create the task run or the pipeline run object to create like a one-shot invocation. Usually if you want to test something out to see if you've got your workflow working just right, or if you wanted something else to call into this. And up above is we also create a Knative eventing sync, as well as the associated transceiver, which creates a serverless service within Knative to handle the creation and the invocation of that task run object. So to give you a little bit of a quick demo of what we have, let's see if I can, oh, perfect. So what we're looking at right now is the customary Hello World example. You'll note up at the top we do have our workflow defined, this one being more of our pipeline object. The resolves indicates all of the actions that would be associated with our workflow, and the on usually indicates the type of action that would happen within your repo. And then right below that one for the action, you'll have some kind of identifier are naming it, the fact that we're using CentOS as our base image, and of course we're just going to run hello with a specification for the environment variable. We do also see that args does allow you to pass in either a string or an array of strings to go in as well, which is one of the nice things about their language. And as far as like some of our translation, we take care of that for you. So with the action command itself, as mentioned beforehand, you have your create, you have your launch. One of the things that we originally had started working on is our own implementation of the parser for the GitHub action workflow syntax. But since GitHub was kind enough to open source it back in February, so that experimental projects such as these can make use of it, we've started transitioning to that one. So now it acts as more of a sanity check on whatever workflows that you feed in to ensure that it does what it's supposed to do. As far as the common global arguments, we do allow for passing in your Git repository. When it comes to creating things such as the collection of tasks with the create command, it is used for being able to not only create a pipeline resource that could be referenced by additional steps in case you wanted to add things to it, but also in a case of specifying like that local directory so that we know which repo to pull the Docker from to build the image. So now, we'll feed that into our hello world. We just feed everything as is, and we have our simple task object. You'll see our steps have actually been broken down. We have our simple command, we have our environment variables, we have our new and improved image, and we also have our name, which has been Kubernetified to resemble their traditional naming scheme. And then we can pass in -t to provide our task run object. And then, give our favorite apply F. Hopefully it'll still talk to my Kubernetes cluster. And we have our objects that are created. it looks like it is still initializing. And it looks like it just finished. So we have our true, we have our success, and we also have a pod name, so we can go here and take a look at any output in the case of failures, or if there was something that you wanted to grab as part of any of the successful messages, and some or other things along those lines. And then, if we were to look at launch, the one thing it does require is that we do pass in a task. Let's see if I can. Come on. Okay, that's right. This one does also require that you specify a GitHub repo. All right. And this one, so here we have our eventing the source definition, specifying going into GitHub, the request for pulling in our credentials, and also the task that it'll create and fire. So that, I believe, is pretty much it. So, so thank you again.
Microphone switch. Awesome. So thank you, Andrew and Chris, again, for sharing your work with us. Like I said before, we're not doing this alone. And Tekton is actually part of a new foundation called the Continuous Delivery Foundation. This is an open foundation where we're collaborating with industry leaders on best practices and guidelines for the next generation of CI/CD systems. And so initial projects of the CDF include Tekton, Jenkins, Spinnaker, and Jenkins X. Now you've seen Tekton integration with Jenkins X. We're also excited that we're starting to integrate with Spinnaker as well. And so these are the current members of the CDF, and we're really excited to work with them on our mission to help companies practice continuous delivery and bring value to their customers as fast and securely as possible. So if you want to learn more about the CDF, please check out cd.foundation to get involved or just kind of watch what's going on.
All right, so what's coming next? So for the CDF, we have a co-located summit coming up in KubeCon Barcelona on May 20th. And if you're interested in what's coming down the pipeline for Tekton pipelines, we're currently working on some exciting features like conditional execution and event triggering and more. And for Tekton itself, we're looking forward to expanding the scope and adding more projects. And we recently had a dashboard project added. And so for takeaways, if you're interested in contributing to Tekton or you're interested in integrating with Tekton, please check out our contributing guide in our GitHub repo. It has information about how to get started developing and also how you can join our Slack channel and our working group meetings, etc. If you're an end user, check out Jenkins X, check out Trigger Mesh Action, and watch this space for more exciting Tekton integrations in the future. And that's it. Thanks so much for listening to our talk.
Yes.
We do have time for questions. If you do have a question, please approach the two microphones that are at the front here.
One quick question. So it's pretty exciting to talk about the Jenkins X and Tekton. do you have any adoption stories to share? Like which companies are actually using it, at what scale, for how long, and what their experiences are?
So you're interested in adoption stories for projects that are integrated with Tekton?
Yes.
I think it's a little bit early for that at the moment. I don't know if, Kim, you want to give more detail.
Yeah, for Tekton, it's pretty early. You've seen some of the companies that are integrating with Tekton directly. If you go to cd.foundation, there's stats for each of the projects that I mentioned to see the companies are involved in everything. But I think, I don't know if Andrew wants to add anything on JenkinsX or.
We're still fairly early with the Tekton integration in JenkinsX. We are pretty much done with switching over JenkinsX's own infrastructure and pull requests and release builds, et cetera, to using Tekton because we want to make sure that it's nailed down by dog fooding it before we start recommending it to users. It's a fairly new project, so there's a certain level of buyer beware if you wanted to go and use it in production, but I think that it's really close to being amazing for production, and like I said, it was so easy to integrate with that, it's just an easy building block to build off of.
And you're using it in production for your own testing?
Yes, yeah. JenkinsX is using it in production for its own testing. However, we also do have a lot of time available to fix it. So, and it's not Tekton that breaks, it's everything else. No, I kid.
Thank you.
So one of the other things is that we are also using it, we do have another command line utility called TriggerMesh itself, which can be used, or which uses the Tekton pipeline components to build the images that would be used for converting your code into the Knative serving services, as well as using it inside our own stack.
Just one question. I saw some mention of inputs and outputs. How does that work? Would it support like binary artifacts being passed from one step to another?
So that is implemented in two different ways right now, neither of which is great, and we're trying to find something faster. The first and the least reasonable one probably is that you can, if you want to, you can upload the artifacts to GCS at the end of a task and then download them at the beginning of the next task. The slightly better but still not great one is we will create a PVC for you and put the artifact onto that, and then we'll connect the PVC to the next task when it executes.
More is definitely planned for the ability to pass more data between tasks, to be able to pass like the output of a command from one task as a parameter to the next task. Not implemented yet, but it fits into the architecture really smoothly and will be there.
Cool. Any more questions? No? Cool. All right. Thank you, everyone.
Thank you.
Just show me how to give you what you need. I'm new to this, but will not miss. Let me take the lead. Overstating expectations, new beginnings, special treatments. Yeah, we really fit so good. I got a crush on the one in the back of the booth. So carefree, let's have fun. I'm just telling the truth. I used to kick it all day, then walk away and totally play the field. But I got one major crush on you, and it's for real. I got a crush on you. I got a crush on you. Overstating expectations, new beginnings, special.
All right, welcome to this session about CI/CD in serverless and multi-environments. This is a topic that we are very passionate about because we have seen that good CI/CD makes a big difference, makes all the difference when it comes to dev velocity in an organization. My name is Martin Omander, and I'm a developer advocate in Google Cloud.
And I'm Adam Ross. I'm an engineer in developer relations in Google Cloud. How many of you have ever deployed to production from a documented checklist? Raise your hands. Oh, that's still a large number of people. Okay. How many of you built a CI/CD pipeline to automatically run tests or deployments? Also, a lot of people.
That's good. A lot of people, yeah.
Okay.
Excellent.
Well, today we're going to explore one particular organization's journey into building their own pipeline for automating these serverless operations, Into the Woods Camping Supply. And before we get too far, you should know that this is a made-up company. They're imaginary, but they've got some real-world problems that we've seen actual organizations face. And as we go through what their decision-making process and their solutions, you might see some things that you can bring back to your own organization as solutions to your problems.
It's a shame they're imaginary, that they have such a stylish catalog.
Yeah, well, yeah. I don't know, that's the wrong shade of red. But one of their problems is they've had slower and slower release velocity because they don't have a good automation pipeline in place. So they don't really know when things go wrong, and when they do, they need to go spelunking into the depths of their code changes to find out how to fix it. So their existing architecture has one monolithic application and a number of microservices, each of them built as a serverless service. And they need to figure out, how do we approach these individual services and modernize how they're operated? We're going to go straight to a demo on what they end up doing by walking through a change. So the new engineering manager has the Friendly Failures initiative, which requires that all the error messages be friendlier. And we change. And let's go ahead and create a quick branch. Stage that code, commit. I hope let's watch conference Wi-Fi in action. That was really fast. Okay. And so now we're going to open a merge request in GitLab. GitLab is the version control platform of choice for Into the Woods. GitHub and Bitbucket are all great products. This just happens to be what Into the Woods uses. And here we're going to open a merge request, which is roughly the same concept as a pull request. So now that I've opened this merge request, it immediately shows us a nice page that has the ability to open in a web IDE, check out the branch to explore it, but most particularly, we see this blue circle here next to a pipeline. A pipeline is the a set of jobs that are run to ensure the quality and deployment process. And that's automatically kicked off as soon as I open that merge request, and we can dig into that and see what it's doing. So here we have a visualized display of different stages for this pipeline, running from testing all the way up through deployment and acceptance. And we're going to go deeper into the individual stages for this later. Drilling into just one of these, we see that there's a linting job for the payment process, and it's taking a little time to initialize this workspace, check out the code, authenticate G-Cloud, and oh, I have an error. Well, that's unfortunate. I guess I should fix that problem. And I also left a comma in the wrong place. So now that I've made a couple fixes here, I'll commit that. And we should see a new pipeline running through. I'm going to just take a quick look and make sure it's running. Yeah. While that cooks, we'll go ahead and move along. Can we go back to the slides?
So, ops automation, one might think it's about computers, but I'm here to tell you it's about humans. And we all have our different views of ops automation. Junior James, he is a pretty junior developer at Into the Woods. He just wants to avoid frustration and bureaucracy, just bang out his code and deploy it and have it be tested and have it work. Process Pari, she's into processes and scripts. She has this idea of ops automation should be about reducing manual toil for the developers. Teamwork Tess, she focuses on teamwork, and she wants everybody to have confidence in the code and bring relief to the team. And finally, the fourth person in the engineering team here is Sang. He's the CTO. He wants to make it really clear to everybody what they're supposed to do as part of a release. And we'll see these 4 engineers here. They are going to discuss and build a CI/CD pipeline, and we'll see the final result at the end of the talk. So they will have to go through various things. There are 6 major decisions that they will need to make, from repo layout all the way through to security. They'll discuss, see pros and cons of various approaches, and arrive at a solution for each one. Repo layout, first one. It's foundational. Before you do this, you can't really do any of the other pieces. There are various ways you can do repo management. So, for example, Junior James, he's heard a lot about microservices and being super agile, and he's like, 1 repo per microservice, right? Keep everything light and really truly separated, these microservices. Pari notes that there are some integration tests. Where would they live? Tess notes that there are some code calling each other across microservices. Where would the API specs for that live? Also, Pari rightly notes that sometimes they need to run shared tools across the code base. That's really easier to have with a mono repo, single code base. And it's, of course, easier to share knowledge. So after some discussion, James is convinced, OK, let's try the mono repo approach. What would that look like? The layout might be something like this. Some files in the root, a docs folder, end-to-end test folder. We have the monolith. They are moving from a monolith to microservices. The monolith is still there, so microservices are still there. One directory for the monolith, one services directory with all the different microservices have their own subdirectories. They want to set up this for growth. Right now they have 5 microservices. They will have more in the future. Who reviews code when you check code in? Well, James has found a cool feature in GitLab, and it's in some other tools as well, where you can add a code owners file. That code owners file tells the system who should be the auto-assigned reviewers for any code that's checked in. And it also documents ownership. If you're just browsing the code, you know who to ask about a particular piece of code. Good, they've decided to go with monorepo. First decision made, 1 out of 6 done, and it's time to move on to number 2.
So next we have continuous testing, getting that test automation going on an ongoing basis so that every change is carefully measured and found to be acceptable to move forward. So junior developers might commonly think, oh, I can just run the tests locally, everything will work out just fine. But more senior engineers know that can lead to inconsistently running the tests and a lot of difficulty making sure that you're testing things the way they operate in production. Running end-to-end tests on cloud services can be a little tricky on your laptop. So they're going to take their existing work on building a testing pipeline and extend it to these new serverless services they've got. And maybe some of those automation engineers amongst you would find that fun, like Pari.
It does sound kind of fun, doesn't it? I would want to build this.
Yeah. So here we have the master branch from the repo. The master branch is commonly used as a release-ready branch to which all changes are merged. Now, shortly after the last release, a bug fix was begun. This branch has been in progress for a while, but in the interim, someone else came along, fixed a problem, and merged that to master. So when we look at this bug fix branch, ready to go, unit test passing, James is excited to merge it. Test knows, wait a second, even though that test is passing, it's showing green, there's a logical conflict between what is now in master and the change that James has been working on. Thank goodness there was an engineer on hand that has memorized all of the code changes that have gone on for the last number of months. So maybe the solution here is to have trustworthy tests. If your automated tests aren't reliable, pretty much all the time, they're not worth that much because you learn to disregard the results of running those tests. And so instead, we want to look into continuous integration. Continuous integration takes this continuous testing idea and focuses on how to make sure that if you accepted that change into your main line of code, would things still be passing? This is done by merging in the master branch here into the bug fix branch before running those tests, performing a code integration, not to be confused with an integration test, which is a bit of a different beast. And as we explored needing to build that pipeline, what kind of tools should we use? Well, one of the most important features that you might have for your CI/CD system would be a configuration as code approach, having the definition of those jobs and all the operations committed to your code repository so that the entire development team and any ops engineers and anyone else around that technical neighborhood can see those changes and weigh in on what they constitute and make sure that you're practicing a good and integrated DevOps sort of culture. Now, as we've mentioned, this team is using GitLab, and they're going to continue to use that for these new services. But in the future, maybe they'll outgrow GitLab, maybe there'll be some other considerations, and they'll consider other products, such as Circle CI, Travis, Jenkins, or Cloud Build, which is a product in GCP. A simple GitLab testing pipeline is made of YAML. I bet a lot of you here were thinking, oh, serverless track, we're safe from YAML, but not always. So here we have a stage that includes a test stage. It's the only one for now, but more will be added later. And every single job in a test stage runs in parallel. And our initial jobs are linting and unit testing. Linting is checking your code syntax, and unit tests are relatively quick to run tests. But we see that both of these are running Node. They're both running some implied service that they're testing against. So it's not necessarily a good fit for a monorepo. It's not testing a bunch of different services. So let's expand on that linting job. Now we have 2 linting jobs. One is testing a Node service named Relay, running the job inside the Relay subdirectory of the repo, and the other is linting a service built in Go, running inside a payment subdirectory. And as James is observing, this multiplication of the jobs is going to result in some slowdowns as more and more services are added to the repo. And so making the pipeline a bit more dynamic is going to help that process. Using almost any CI/CD system, you can introduce a little dynamic logic and take advantage of the fact that you're probably using version control. And you can run slightly complex commands such as this git diff here to list all the files that have changed and maybe only run the tests that apply to those files. And as it happens, GitLab has a trick for that. In the configuration, if you are running your testing pipeline for a merge request, you can also specify to only run that job if a file changes in a particular subdirectory. So here I see it is configured to only run if a file in the relay service has some kind of update. And you might be thinking this is getting a little complicated, but that's a trade-off from going with a monorepo. The tooling is often a little behind on that compared to having a service per repository. Lastly, with the monorepo and having all these services in one repository, there might be a tendency to have some of the operations leak into top-level directories or into this configuration file. Well, having those operations defined in the world's best-known task runner, bash scripts, you can get them isolated into those same subdirectories and make sure that those responsible for an individual service are also responsible for all the details of the operations. And perhaps in the future, this Into the Woods dev team will look into moving to something else that's a little bit more sophisticated than bash, maybe using makefiles or Bazel to run their jobs. And so by the time all of these steps are built in, we have a few different stages potentially coming together on just the testing pipeline. A pre-check here is showing the use of shellcheck, which is a utility that applies linting checks to bash scripts. Then test, running linting and unit tests against each of the services, and build, running any builds for those services that need a build process.
All right, so that was the end of step 2. Now we're 2 down, 4 to go. The next decision the team at Into the Woods need to make is how to manage automatic deployments. So there are a number of ways to do deployments, all the way from how CTO Sang did it before he was a CTO when he worked in a startup 20 years ago, through something that a junior developer might do with scripted development. The team really, though, they really want to focus on continuous deployment and delivery rather than these sort of semi-manual approaches, because that leads to more reproducible deployments and higher velocity. So James, he is happy junior developer. He checks in a bunch of code. It tests OK. He merges them, ready to go on the release train. Let's deploy it to production. Tess says, hold on a minute. How do we know that this won't break? Pari has a solution. We deploy it to staging. And we deploy it all the time to staging and keep running tests there. And that way we can see if it would break if we were to deploy it to production. Let's see what that would look like.
So adding deployment to this whole pipeline is really just adding an additional stage to the end of what we've already built. And that stage will include some new deployment jobs. These jobs bring with it more YAML for us to look at. A deploy job definitely needs to run the deploy process, and that will probably involve using gcloud, the command line SDK that allows you to run operations against GCP. So we have a shorthand authentication for gcloud to the cloud platform, and we'll go into more detail on that later in the security section of the talk. And then under the script, we're changing directory into the relay service, and we're running our functions deploy for that cloud function, which probably should be wrapped in a deploy script itself, but it's more clear this way that that is not a very complicated script necessarily. Now, if you were going to deploy instead a Cloud Run service, which you may have heard today across the keynote or other sessions, you know that you are dealing with serverless containers. They have a bit of a different deployment model. And so you are deploying a container image from Google Container Registry to your Cloud Run service. But it is just the same, a one-line command to make it happen. So we have added the new deployment jobs to the end of our pipeline. And so on every change, it will run through each of these stages, ultimately resulting in deployed code.
All right. 3 down, 3 to go. The next step is environments. How do we deal with that at Into the Woods? So just a quick reminder what environments are. We have the architecture, that's the design, right? What compute is in a microservice, what storage is in a microservice. Environments, those are instantiations of that architecture. And we have them for various uses like demo and test and so on. All right, so the team sits down to discuss this. Pari says, let's minimize administration by having all these environments live in one GCP project. James is like, no, let's have them more isolated. Let's have one environment per GCP project. We'll have many, many, many projects. Well, we need to look into the pros and cons of each approach. So, if each environment is a namespace, here we have QA and stage for the payments microservice. We have a payments compute part and a payments data part, payments for QA and for stage. So, all in one project. It has certain advantages. Pari is right about that. There is easy access management. You go into IAM once and set that up. It is also easy to just list all your resources in a project because it's all right there in one project. However, there are some global project settings that you might have seen around regions and data, app engine, data store, and so on, that we need to set once per project, and that could be hard to make all the different environments use those those global settings. Also, it's extra work to connect the compute and the data for these. As a matter of fact, it could get so bad that you cross-wire and there's crosstalk between environments. So the team decides not to have everything in one giant GCP project. Well, the alternative is every environment is a separate GCP project. So we have a staging project, and we have a QA project. So the disadvantage of this is there's more management, of course. We need to set up user access for every single project. Another one is we had to keep track of all these projects. What's good about this, though, is that we have really strong isolation with no crosstalk between environments. So the team decides to go with this approach. Now the question is, how do we avoid QA bottlenecks? In the old pre-serverless days Into the Woods, there was one QA environment. And if you were working on a branch, you really wanted to test your stuff on that, and everybody was fighting to get their stuff on there. Well, new environments, everything is serverless. We can spin up as many environments as we want, right? Well, we do need to keep track of them. So maybe we should give each developer their own development environment and their own QA environment, rather than infinite environments. Let's see what that would look like.
So now that we have a plan around the number of environments, we have production, staging, and then a QA environment for each developer and a development environment for each developer so that they can experiment. And each of these environments is related to the code changes in some way. Production is going to be tagged off the master branch when releases are cut, and master branch is going to automatically deploy to staging, and then individual feature branches will deploy to QA. One of the challenges with this arrangement of associating different lines of code to different environments is how the CI/CD system understands how to route that. And for that, we have a bit of bash magic. Here, if the branch is master, this first part of the code says, oh, this must be for stage. And after the else statement, we are looking up a variable from the environment to associate the developer that pushed that last change, and that will map to that developer's environment. Now, you could hardwire that and say, oh, we're going to just use the test environment today. But by providing that little bit of separation, it provides space to then continue to expand this later to perhaps have multiple environments that might be routed to. And so using this arrangement, our Our earlier fix to the master branch is going to automatically deploy to the staging environment, and bug fix number 1, as it's going through its troubleshooting cycles, will be deployed to James's QA environment. Once that is approved to be merged into master, it too will be automatically deployed, updating the staging environment to the current picture of what would happen if a production release were tagged. And of course, once a release is tagged, production will be deployed.
All right, the team has decided on 4 out of 6 decision points. The next one is serverless testing. Now, this is a little different than regular testing. If you're testing something you run in your own data center or on-prem, serverless is a little bit of a different beast. So there are, of course, different types of testing. Junior developers think of unit testing. There's integration testing, system testing. Sang, the CTO, of course, he thinks more about end-to-end testing. So we have this whole spectrum of tests. One isn't better than the other. Some are really useful to developers. Some are more useful to business people. We need a mix of all these different types of testing. How do we do that? Well, so here again, we have bug fix 1, the branch James has created. He needs to merge this in. Let's see what testing happens at each place in this scenario. So whenever he commits code, that's the heart. James loves his code. It's a heart. There is unit test and linting in the CI workspace. So this still has nothing to do with serverless or nothing to do with Cloud Functions or Cloud Run or anything like that. It's auto-deployed, as we saw. It's auto-deployed to James-QA. This is James' own QA environment. And when it's auto-deployed there, there are automatic system tests running there. They run in the context of serverless, so this run on GCP, and can use all the GCP services and databases and such. They're bigger than unit tests. Then when he merges into master, there are lint tests in the CI/CD system, and then it's auto-deployed to staging. There are system tests run, just like on James-QA, and there is also these more business-focused end-to-end tests are run in staging. And there, all branches are mixed up in staging too, so we test all of them. Broadly speaking, there are 2 types of testing environments here. Inside the CI/CD system, that's good for simple testing, like unit tests and linting. But when you actually test stuff like serverless databases and making calls and you're exercising more of GCP, then you actually need to run those tests on GCP. So there are various serverless options. You may know of serverless functions, Cloud Functions. You may know of App Engine. And earlier today, you heard about Cloud Functions. Cloud Run. Let's go through and see how you would test each one of these 3 serverless compute options. Testing a Cloud Function, you can do that locally. There are various ways of doing it. We really recommend, if you want to know more about testing Cloud Functions locally, you should go to our coworker Stuart's talk on Thursday afternoon, where he will dig into more details around this. For unit testing, you would create mock HTTP requests, and for system testing, well, in that case, you deploy to GCP, you get a URL, and then your test system hits that URL. Also worth noting here, Tess notes that it's good to have sort of secondary, more complex logic in sort of secondary functions that aren't directly called. So that makes it easier to just sort of test those and troubleshoot those in a local environment before you deploy everything up to GCP. On App Engine, with the modern runtimes on App Engine, you do your local development and test using your regular tools or your regular frameworks, whatever you're using, Flask, Express, etc. Unit testing, there are mock libraries that mock out like task queues and databases and things like that. And for system testing, it's just like Cloud Functions. You deploy it to GCP, you get a URL, and your test system hits that URL. Also worth noting here is that App Engine has been around for a long time, so there's lots and lots of content, lots of articles and blog posts by Googlers and non-Googlers about how to test it. That was 2 of the serverless compute options. What about the third one that we heard about earlier today?
Well, since Cloud Run is new, let's talk a little about what it is to set the groundwork for how we would test in it. Cloud Run bridges the worlds of serverless and containers, providing a way to run a containerized service serverlessly. This means that you can build a service in a pretty conventional way, wrap it in a container, and deploy it. If you have no ops team, like Tessa's team seems to have, you can use managed Cloud Run. And otherwise, you can have Cloud Run on GKE, where you have a Kubernetes cluster underneath that your own ops team can manage. And with this arrangement, all the considerations of how you would test a container come into play. For local development and debugging, you might run your service locally using your standard tools, or you might choose to build that container locally and run it so that you are more closely simulating the production environment. For unit testing, you could also do the same. Run your unit tests the way you normally would when building code locally. Or you might also build a container that's loaded up with a number of development dependencies on top of the same production dependencies that you have on Cloud Run itself. And in that case, you can run the unit test there and have available any of the system packages or other resources that are part of your service container. For system testing, much as we were suggesting with Cloud Functions and App Engine, go ahead and deploy your service to Cloud Run. It'll only be running when you're testing it, and otherwise it will scale to 0 and not cause you troubles. With all of the different jobs that we've been looking at with the CI/CD system, there is this workspace that is spun up in which we're running the linting checks, running unit tests, and running gcloud to trigger deployments. And one of the problems you might find are the performance concerns of what it takes to initialize that environment, then run all the tests. And waiting for tests is kind of a bummer. So one thing we can do is find ways to optimize just how big those workspaces are. Can we use a smaller container image as part of that CI/CD workspace to initialize the environment? Now, the main Cloud SDK Docker image that you might use in a CI/CD workspace is pretty fully loaded. It's based on Debian. It has a number of emulators and other things that you might not need initially in a service. So you might want to go with a more stripped-down approach, using an Alpine-based image. That's a lean distribution of Linux that's really popular in containers, and add to it just the pieces you need, in this case, for your Cloud Run work. And so the team here has built a slightly customized version of the Cloud SDK, pulling a static binary from Docker for the Docker client, and then adding that to the official Alpine version of the Cloud SDK Docker image, and installing the beta components which you need in order to interact with the Cloud Run service. This can lighten the size of this workspace container from around 700 megabytes to 120 megabytes, and that can save you a good minute of download time on each of those jobs. Another problem that can emerge from the particular way we've outlined the system here is the tendency to only trigger the tests when a developer takes an action. For continuously evolving software, that seems fine. You'll trigger the tests on an ongoing basis, and they'll continually be exercised. But for a mature service that has already been built and is running happily in the background without anyone the wiser, you won't notice if bit rot sets in and makes that service unstable if you were to try to deploy it or try to issue changes. And so rerunning the deployment and testing process on all your services is a valuable way to make sure that they are all staying in a healthy state, whether or not developers are actively working on them.
So with this, they've made decisions in 5 out of the 6 areas. They're almost there. The CI/CD pipeline is almost complete. There is one area that is very important, you should not forget about, of course, that is security. So the team sits down to discuss security. Pari notes that she needs, for her deployment scripts, they need some secrets to deploy to GCP. Tess notes that to hit the payments API that the payment provider has, she needs an API key. So here we see, right away at the beginning of the discussion, two types of secrets. We have operational secrets on one hand that deal with just managing all the builds and CI, CD, all that stuff. And then we have runtime secrets that are used by the runtime for when it does what it's supposed to do. At that point, James comes in and says, well, we have secure source control. This is not an open source project. Just deploy it all to source control. At this point, Pari has to come in and gently guide James and say that this is not something that one does. There could be accidental disclosure. I mean, we don't want developers to see the passwords and then accidentally enter it somewhere else. We also have contractors working from time to time at Into the Woods. Also, sometimes we share code with other companies. We could even have people potentially break into our source control system. These secrets need to be in a safer place than source control. How do we do this? Pari has a proposal. So let's manage the operational secrets separately from the runtime secrets. So everything starts with the repo, right? We have the source code there. No, James, no secrets in the source code. Then that code gets pulled in by the CI/CD system, and the CI/CD system has the operational secrets in it. One operational secret is the service key, that service account key, that is used to deploy code to GCP. The other operational secret is the name of a storage bucket. That Google Cloud storage bucket. And that is deployed or set as an environment variable in the runtime environment. So the runtime environment can read it. What does the runtime environment do with the name of a storage bucket? Well, when it needs a secret, like the API key for the payment API, it can go and hit that, read from that cloud storage bucket, and get that runtime secret. And what's cool about this is that now that reading of the runtime secret is managed through IAM in GCP, which means it can be really locked down who can read it. James can't read it, for example. Pari can't read it. Maybe none of the developers can read it. Maybe it's only the CTO, Sang, who can read this, and the runtime environment. So setting up this environment means operational secrets, runtime secrets separately. Let's talk about how those operational secrets are put into the CI/CD system. In GitLab, it's easy. You just enter them in the web UI. This means there's no file sitting around with these secrets. As soon as you have a file, it's very dangerous because somebody might accidentally check it in, right? In this way, somebody types them into the web UI. Nobody saves them anywhere. Once you type these in, let's see where they go next.
So if we look at the particular variables we have here, the third one down is the service account key. This is a key associated with a service account from IAM, and it's been entered here in a base64 encoded way. That way, if anyone accidentally looks at it, takes a screenshot, echoes it out to a terminal, they've not accidentally seen it. It's a nice security through obscurity. And so using that, every single job that runs in the CI/CD system can then expand on that key, taking that environment variable, decoding it, and then using that to authenticate G-Cloud so that it can go on to pretend to be that service account as it goes through and runs any deployment or other commands that you need to run. Now, as Pari notes here, you might find that this is a little bit easier if you were running from Cloud Build, because with Cloud Build, instead of needing to manage this key separately, you can instead grant permissions to the Cloud Build service account directly, and it will operate with that, no additional keys needed. So once you have this service account, what exactly do you do to give it those accesses? All the permissions that it needs to run builds and deployments and perform other operations. You could give it the project owner or editor role. That's the easy button way to do it. But in that case, if anything were to expose that key, the blast radius of that would be encompassing almost all the things that can be done with your GCP project.
Yeah, some could just take down the production environment with that key, right?
Or just delete it, yeah.
Delete it. Ooh.
So instead, a least privilege approach is much better. Figure out exactly which roles and cloud storage bucket ACLs you need to have and assign them to the service account. That way you know that you've got the minimum exposure. What's more, since we've charted this course of every environment being its own GCP project, we might want to have a central repository for things like build artifacts and this service account, so that we can have one central source of authority and then deploy into each of those other environments. In that case, we're going to need to collect all of the different roles and permissions for the deployment process of shipping resources, shipping cloud functions into stage and production, and give that to the service account on a cross-project basis. This can be done by identifying the email address of the service account and adding it like a normal user to other projects. For runtime secrets, we've charted this course of using a cloud storage bucket as a kind of vault, which we are going to have the runtime function look up and pull in the secrets as needed. Here we have a little bit of bash magic in the first couple lines of the slide, which is looking up a cloud storage bucket that is specific to an environment, using a little trick for dynamic variable names in bash. This bucket name is then passed into the function or Cloud Run service or App Engine app when you deploy it, so that when those things start up, they can load the secret and keep it in memory to reuse for further requests in the future. Now, with all this talk of giving permissions and roles to a service account with keys exported to another system, there's a lot of access there you're still exposing, even though you're trying to get a least access approach. Being able to deploy to production is not a trivial thing. And there are a number of ways you might approach that. Since we're using GitLab, you might take the open source version of GitLab and host that on GKE. And I believe there's a Code Lab session for that on Thursday, exploring how to do that. But one approach that Pari and the Into the Woods team is exploring here is splitting up the responsibilities of what different systems will do. GitLab can be responsible for everything up through QA, and maybe Cloud Build will handle all the operations for staging and production. Since so many of our operations are wrapped up in bash scripts, they can be easily executed by any runner. And so GitLab is going to perform the same operations as Cloud Build through the lens of those scripts. And so as we've built out the additional stages, we might even add deployment and an acceptance stage for those end-to-end tests. Let's go ahead and see if that demo from the start of the talk has completed and we have a successfully deployed service. So here is the GitLab CI pipeline that we started earlier, and now we see we have some green check boxes, and the last one here with the exclamation mark looks like an accepted failure. But I'm not too worried about that right now. I want to see, did my QA environment get updated from this change? And looking into this terminal output from the CI system, it looks like it ran through all the steps, figured out an environment, and deployed to a demo environment. And here we have a URL to look at our Cloud Run service. Well, that command disappeared, didn't it? Well, since Cloud Run services deploy in an authenticated-only way, and I don't have that command handy, we will move on. Go back to the slides, please. Take it away.
All right. So now that they have the whole CI/CD pipeline set up, what have they learned along the way? Well, first, Junior James, he was a bit concerned about this CI/CD. There would be a lot of bureaucracy. He's happy that CI/CD actually helps him. Pari, who writes a lot of these scripts, she sees that monorepo, that adds complexity in the scripts, but it is worth it. Also, secrets management is always tricky. Tess notes that serverless makes CI/CD easier because you can test in environments that are exact carbon copies of your production environments. And also, those environments don't cost anything if they're not running. Finally, Sang is really happy that they can release software more predictably. And that is the content we have for you today. If you liked what you heard here, we'll take questions in a minute. We have 5 minutes for questions. I just want to put a bug in your ear. If you liked what you heard here, there was a talk earlier today about DevOps in a serverless world. Our coworker Alexei gave that. It's about logging and tracing and debugging in production. Really good talk. You should see the recording of that one. There is another talk about Cloud Build on Thursday, where they're doing a lot of what we saw here in GitLab will be done in Cloud Build instead. Or if you want to learn about the deployment manager, that's another piece that helps you with deployments in GCP that we didn't touch on. There is a talk about that on Thursday. You should also take a chance to go down to the GitLab booth downstairs, 1607. Great guys. They will tell you much more about GitLab. Thank you very much for your time. You can enter your questions at this bit.ly link, or go up to the microphone if you have questions, and we'll take 2 questions before we wrap up.
Figuring out the architecture.
Sorry, I do have a question.
Yes, sir.
So you were using, just curious, when you're doing branching strategies in GitHub or GitLab, why do you choose these over single branch development, where like single branch of code will go through to QA, prod, staging, prod, whatever?
So your question is, why not cut a feature branch and then take that to QA, to stage, and to prod in its own right?
Sure, yeah.
So in this case, we have the master branch as a source of truth, in which only has reviewed and at least somewhat tested changes. That way there's a little bit of protection for production, and you know that at any given point, the code that you might release to master is stable and understood to be safe. So as you are going to make new changes, you can check that out for master and then merge it back in when you know it's ready.
How about you do everything on master, you do bug fixes in master or whatever, and whenever you're ready to release, you cut that release branch at that point. So you don't have various fixed branches around, and then you will have out things for in between branches.
There are so many different branching strategies around Git. This one is a basic strategy that I have found is a pretty good starting point for small teams. But if you are an individual person, then it might be worth just working off of a single branch. But I find in general with Git that working against the one branch is often going to lead to problems with having issues that come from multiple changes in progress from multiple developers conflicting.
Okay, probably there are more detailed conversations.
We'll be around.
Yeah.
Come up and we'll talk, yeah. Is there one last question before we wrap up? Please submit feedback. That is how we know if we're doing the right thing or not. If you have additional questions or want to hang out and geek out about CI/CD, come up here and we'll continue discussing. Thank you very much.